Hi students, welcome to Vedantu J English. I'm Diksha Kaushal, your chemistry master teacher, and very welcome to the class. Guys, this is day 2 of Organic Chemistry Challenge, where we are going to complete organic chemistry in 5 days. Right? So today we are going to do isomerism topic, where we are going to talk about structural isomerism, and there the most important topic is tautomerism and metamerism. If you talk about other things, that is stereoisomerism, based on that, students usually skip that, right? So that is geometrical isomerism and optical isomerism. From geometrical isomerism, they can ask you questions from cis, trans, E and Z configuration. And from optical isomerism, they can ask you questions like either they can ask you total number of optical isomerism, calculate the number of geometrical isomerism, calculate the number of stereoisomerism. That means both geometrical and optical, right? And the third kind of topic that they can ask you is conformers, conformations of cycloalkane and alkane, from where the question that is asked is basically either on cyclohexane or on ethane or butane, right? Eclipsed configuration, right? All these conformers, not configuration, conformers they can ask you, right? Okay, so are you all ready? Yes, we are going to work hard. So everybody hashtag JMains 2025, spam it in the chat box, okay? So that I can see your energies in the comment section. Because see, completing GOC in just 5 days, not GOC, completing full organic chemistry in 5 days is a task. Yes, it is a task. It's not easy. Yes. Okay. But I'm going to make it easy for you, right? Because I have already done a lot of hard work for you guys, right? So it's not only just the concept, it is concept plus the previous year questions that we are going to see. So it is going to be the overall what you need 1 month before your preparation. Okay, yes. Yes, I'll explain the concepts in depth. Like in depth, you will say that what is required for your JEE means, that I will explain, right? Okay, what is not required, that we will not focus on, because right now the target is to gain marks. Knowledge. So you already had a lot of time to gain knowledge, but right now is the time to take marks out of that knowledge. So this is what we are going to focus on today. Yes, physical chemistry we will do after organic chemistry. Right now, like Arjuna, right? You know Arjuna in Mahabharata, right? So in Mahabharata, there is Arjun, right? So Arjun is always like target on one thing. So the target right now should be organic chemistry, inorganic chemistry, physical chemistry. Keep it aside for right now. Okay? Yes. Chalo. So now let us start the session without wasting any time here, right? So firstly, guys, what is isomerism, right? What is isomerism? See, this session is basically divided into 3 parts, okay? What are these 3 parts, guys? First part is I'm going to talk about structural isomerism, tautomerism, and geometrical isomerism, that is cis, trans, and EZ configuration, right? So after this, we are going to solve a lot of questions of JEE mains on these topics, right? Then I will jump to optical isomerism and calculations of isomers, right? Then third topic will be conformations, right? Conformers of ethane cycloism. That is a very small topic, right? Okay, so first start is your structural isomerism, tautomerism, metamerism, and geometrical isomerism. For that, you need to know what exactly is isomerism. So guys, isomerism is when you have rearrangement of the atoms, right? That means the molecular formula is going to be same, but because of the rearrangement of the atom, there are some changes in the structure. Or sometimes if the structure is exactly the same, there are changes in the arrangement in the space, right? I am standing like this or like this or like this. That is called stereoisomers. So basically, isomerism is divided into 2 categories. First is structural isomerism. Second is stereoisomerism. Structural isomerism means there is change in the arrangement of atoms only. Stereo means the structure is same, but there is change in the 3D position, right? Whether it's like this, it's like this, it's like this, it's like this, whatever it is, right? Okay, so that is your structural and stereoisomerism. So in structural isomerism, there are few parts, right, that we will talk about, right? In stereoisomerism, further we have few parts that we will also talk about, right? Okay, so firstly, let us focus on the structural isomerism. Structural isomerism, guys, you will find it, ma'am, so simple, ma'am. But see, the questions, either they will be asked directly on, wait a minute, tautomerism, directly on tautomerism, which is very, very important, or the questions will be match the following, mix match of these 5 types. So what you need to know about this thing? Firstly, you need to know the definitions. These are very, very simple, guys. This is actually very simple, right? So if they ask you, usually they are asking you match the following. They will not ask you what is chain isomer. That is very simple, right? They will either ask you the miss and match, or they match the following of chain, position, functional, ring chain, and metamers, right? Metamers also they ask individually, right? Then individually 2 topics are asked, that is tautomerism and metamerism, right? Okay, got it. Now, one by one, firstly is, what is chain isomer? Chain is, you just need to do the IUPAC naming. If the parent chain is different, that means it is a chain isomer, right? For example, if I talk about these 3 isomers, okay, if I talk about these 3 things here, it is 1, 2, 3, 4, 5, right? So here it is 5 carbons in the parent chain. 1, 2, 3, 4. 4 carbons in the parent chain. Here it is 1, 2, 3. 3 carbons in the parent chain. When your parent chain is different, that is called as chain isomers. Okay, that is called as chain isomerism. So here we will say this is your chain isomer. Okay, next is position isomer. So what is exactly position? Chain to clear now. Chain is when your main parent chain is having different number of carbon atom. That is called chain isomerism. Position isomer is when the position of the functional group is different, right? When the position of the functional group is different. Same molecular formula, same parent chain, different position of the branch or the functional group. For example, if you talk about this thing here, this is OH, this is also OH, right? If you talk about the parent chain here, this is 1, 2, or you can say 1, 2, 3. This is 1, 2, 3. So parent chain is 3 carbons only. So it is not a chain isomer. But if you talk about the position, this is on the first position, this is on the second position. So this is going to be position isomer. Okay, this is going to be position isomer. Okay, third thing is, okay, another example of position isomer. Here also you can say the parent chain is same, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Parent chain is same only. Parent chain, there is no difference. 6 atom both are having. Here it is first, here also it is first. But here it is second and here it is third. And because of this difference, we can say this is a position isomer. Okay. What about this one? Now this is important, okay? This is important, okay? This is very, very important. This is, guys, I am doing a very quick revision. Right? Why I am so energetically so high? The reason is because I want each and everything that I am uttering, that I am speaking here to be in your head. Okay, that should remain in your head. Okay, so now here it is. Thank you so much, beta. Thank you so much, Akmal. Very good, very good. Akmal, whatever questions you have, okay, regarding any other topic or regarding, ma'am, if you have any suggestion like, ma'am, please, I need this particular session, you can always comment it down because chats will go away. Hai na? Okay, right? So now let us just focus on the topic here. I want you to answer in the about these topics, okay? Not about something randomly, okay? Got it? Chalo. Now, here it is position isomer, right? Now, this is a very, very important example. Right? If I ask you this, students will be like, ma'am, yes, this is a position isomer, right? Will you consider this a position isomer or not? Will you consider this a position isomer or not? This is something they can ask you in JEE, right? This is something, if they are asking you this in JEE, then I would consider this is a very easy question. But if they ask you this in JEE, I would say this is a good question to be asked, right? Because here you need to have conceptual clarity. Now, here you can say, ma'am, 1, 2, 3, 4, 5. Ma'am, 1, 2, 3, ma'am, 1, 2, 3, 4, 5. Ma'am, yes, position is, this is third. Ma'am, this is 2. So this is a position isomer. I'll say no. You are wrong here. This is not a position isomer. Reason is because if you talk about the numbering, guys, if you have a carbon containing functional group like CHO, right, like this, then the numbering is going to start from that particular group. So answer will be, this is 1, this is 2, this is 3, this is 4. Okay, here it will be, this is 1, 2, 3, 4, 5. Right, this is the longest chain that I have. This is the longest chain that you have. That means, can I say that the parent chain is not same? Right, so hence it is not position, but this we will say, this is your chain isomer. Okay, this is your chain isomer. Okay, this is chain isomer. Very good, because there is a carbon in the group. Here when we are talking about this OH here, OH, we know that how we do the IUPAC numbering, right? IUPAC numbering is not from OH only. That is, we need to give it the highest number, right? So that thing is applied here. Okay. Third is metamerism or metamers. From here, the questions are frequently asked. Okay. You will see for yourself that how the questions they ask you from metamers. Now, what are exactly these metamers, right? Metamers is like, for example, this is one city, number A, this is city number B, right? And this is the river, okay? This is the river, this is the river, this is the river. And you want to cross from this to this position, that there will be one bridge, है ना? You will cross from A city to B city with the help of a bridge, right? And metamerism is also present in bridging ligands. For example, bridging, not ligands, from bridging groups. Bridging functional groups like C double bond O, right? Bridging functional groups like ether, right? In the bridging functional group, where you have two alkyl chains, one here and one here, right? One on each side, their metamerism will be shown, right? So now, what is metamerism? Metamerism means if you have R dash here, here you will have a different chain, R double dash and R triple dash. So now these two are going to be the metamers of each other. I'm going to give you some examples of bridging groups. The bridging groups are O, ROR, RCOR, RCOOR. Right? These are the main bridging groups that you will see. Right? Now, here how they are going to be different. If you talk about this particular example here, CH3, CH2O, CH2, CH3, right? This is your R, this is your R. Now, students, what they get confused is they think that, ma'am, this R and R should not be equal to each other. This is not what I am saying. I am comparing one compound with the other compound. I am saying that if this is ethyl, this is also ethyl, then these should not be ethyl. Okay. Then if this is methyl, and this is propyl, I can say that here two alkyl chains are ethyl and ethyl. But here those are methyl and propyl. That means they are metamers of each other. Right? Okay. So that is called metamerism. Next is functional isomer. In functional isomerism, as the name is saying, that functional group is different, right? So here, if you talk about, there are questions directly asked that alcohol is a functional isomer of which of the following? Ketone is a functional isomer of which of the following, right? Carboxylic acid is a functional isomer of which of the following, right? These kind of questions are asked. So if you talk about alcohol, it shows functional isomerism. Here you have OH. With the same number of carbon, hydrogen and oxygen, you will have a compound which will be ROR, and that is your ether. That means alcohol and ether are functional isomers of each other, right? Here you have carboxylic acid. Carboxylic acid is what? Carboxylic acid is RCOOH. Now, if you divide this R into two parts, so it will be RCOOR. That is your ester, right? So, ester and carboxylic acid are functional isomer of each other. Next, we have cyanide and isocyanide, right? This is CN, this is NC. So, number are same, but the functional group is changed. This is cyanide, this is isocyanide. The group, the properties are entirely different, right? So, this is cyanide and isocyanide and isocyanide. That is the functional isomer. Next, we have ketone and aldehyde. That is also the isomer of each other. Ketone and aldehyde, right? Ketone and aldehyde. Here you have RCOR. This is RCHO. That is also the functional isomer of each other, right? Okay. Huh. Ene and ine can also show functional isomerism. That is possible, but you have to see whether the number of carbon atoms, the hydrogen atoms are same or different. Okay, Shubham? Very good. Chalo. Now, next is ring chain isomer, and a very simple question has been asked in your JEE based on ring chain isomer. Very simple question. Now, guys, we know that ring and chain, when they are getting converted into each other, or you can say, if this is the formula of ring, this is also the formula of chain. Now, if you talk about alkene, that has a formula CnH2n. This formula is for two things. This formula of alkene is of two things. First is alkene. First is the same formula is for alkene. Other is for cycloalkane. Cycloalkane. That means if I have anything like this, they will coexist as either, not coexist, I would not coexist is not the right word. I would say with the same molecular formula, either it can be alkene or it can be cyclohexane. There is no cycloalkane. There is no other possibility here, right? So here, if I talk about this is alkene, this is 3, 4, 5, 6. This is 6 C3H6, right? This is a double bond here. What about this? This is CH2, CH2, CH2. Again, this is C3H6. So you can say that the ring is getting ring and the chain. Both are having the same molecular formula but different structures, right? So alkene and cycloalkane will show ring chain isomer, right? Okay, got it, students? Got it? Any problem here? Any problem here? Because now we are going to start a very important part of structure isomerism, from where definitely the questions is asked, right? Very, very important part. Okay, is there any problem till here, guys? Any problem? Now, we are going to do tautomerism. Mark very, 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 very important. Why, ma'am? You will see that when we are solving the question, every other question will be of tautomerism. Reason being because this is actually something from where high level questions are also asked. I won't say that very simple questions are asked here. Here they ask also complex questions. Okay, complex questions. Complex questions are also asked from this topic, right? So we have to do this topic in detail, in depth, every single question that they can ask you. If you see this particular lecture of tautomerism, trust me on that, the question will not go wrong. I can assure you that, right? So I'll give you a very simple trick of tautomerism, and that will not only help you here, but also in other parts. Chalo. Firstly, ma'am, what are the other names? Cryptotropism, allotropism, despotropism, prototropism. These are the other names of tautomerism. Ma'am, are they asked? No. Right? This is just for your knowledge that, okay, you should know that cryptotropism, allotropism, despotropism and prototropism is also tautomerism only. These are the other names. Okay. Ma'am, next thing. Now, guys, first thing is the question that they ask you. First kind of question, if you have ever gone through the previous year question, one question that you will see that is continuously they're asking is which of following is not or is showing tautomerism. Tautomerism, a very, very, very highly predictable question, right? So they ask you that which of the following is showing tautomerism, right? Okay, yes, beta, this is sufficient, right? More than sufficient. Which of the following is not showing or showing tautomerism? They will give you some structures. How you will predict that? For that, you need to know the conditions here. You will feel that, ma'am, the conditions are, ma'am, similar to hyperconjugation, but hyperconjugation and tautomerism has no relation, okay? The conditions are kind of similar, right? Now, the condition is H positive transfer intramolecular, okay? That I'll tell you in the mechanism itself, not in the mechanism. I would say when you are converting enol to ketone form, what you are doing, that I'll show you H positive transfer here. These are the two conditions that you need to focus on. First thing is your alpha carbon should be sp3 hybridized, and this should have at least one hydrogen. At least one hydrogen it should have. What I talked to you? That alpha carbon should be sp3 hybridized. That means if I am talking about a ketone here, right, something like this, this is the alpha carbon. This alpha carbon should be sp3 hybridized and it should have at least one hydrogen. Only then tautomerism is possible. Otherwise, tautomerism is not possible. And remember one thing, there are two kinds of tautomerism. One is 1-3 system, other is 1-5 system. If you want to solve the questions of JEE, you need to know 1-3 system and 1-5 system, both of them. Right? So I will give you a simple flow chart of how to predict whether it is 1-3 and 1-4. For that, you need to have patience for next 10 minutes. Okay, next 10 minutes, after 10 minutes, tautomerism will be clear in your head. Okay, for that you need to understand every single like that I am telling you in next 10 minutes. Okay, so these are the two conditions, alpha carbon sp3 and it should have at least one hydrogen. Okay, ma'am. Now, how it is done? How it is done? 1 to 3. What we will do? 1 to 3. Ma'am, what is this 1, 2, 3, 1, 2, 3? 1, 2, 3 is a game that we play. Okay. So you will see in organic chemistry, a lot of times we will play this game. When we will do rearrangement, when I'll solve important reagents, I'll also teach you rearrangement of carbocation. There also we will do some tricks like this only, right? So now here it is 1, 2, 3, right? What you need to do, just write it as it is. C, H, 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 okay, C double bond, okay. This is C, H, H, H. Now what you need to do here is 1, 2, 3. Now what you will do? The double bond of 1 and 2 will shift to 2 and 3. Okay. The double bond of 1 and 2 will shift to 2 and 3. Okay, ma'am, done. Now, I told you hydrogen transfer. From where the hydrogen will transfer? Double bond of 1 and 2 will shift to 2 and 3 and the hydrogen of this 3 will shift to this one. Okay, so here just erase any of the hydrogen here and shift it to here. So this is your keto and this is your enol form. This is your keto form. This is keto form, right? And this is your enol form. Got it? Okay, 1, 2, 3. Shift the double bond of 1 and 2, attach it to 2 and 3 and hydrogen will be transferred to the first position. Okay, 1, 2 to 2, 3, then 3 to 1. 1, 2 to 2, 3, then 3 to 1. Okay, 1, 2 to 2, 3, then 3 to 1. 1, 2, 3, 3, 3, 1. Okay, got it? Chalo. Now, here too we have done the same thing. Now, beta, why this is called 1-3 system? Can you tell me why this is called 1-3 system? It is called 1-3 system because oxygen is at first position and carbon is at third position. That is why it is called 1-3 system. From where the hydrogen is being shifted, that is at third position, oxygen is at first position. So there is a hydrogen transfer from third position to first position. That is why it is called 1-3 system. Okay, chalo. Now, we will also see some examples here. Which of the following is going to show tautomerism? The same kind of question they ask you in your JEE, right? These are your JEE previous year questions only, right? These are your JEE previous year questions only, guys, right? Now, here, keto-enol tautomerism is shown by which of the following? This is what they are asking you, right? First thing is, ma'am, we will see the alpha carbon, whether it's sp3 or sp2, right? This alpha carbon is definitely sp3. This is also sp3. Why? Because it does not have any double bond here, right? Okay, no double bond, no triple bond. This is also sp3, right? Now, this is also sp3, no double bond, right? This alpha carbon is not sp3, this is not sp3. Okay. Now, we need to see which has alpha hydrogen. Here you have 2 alpha hydrogen. To complete the tetravalency, you will have 2 alpha hydrogen. Here you don't have any alpha hydrogen. Here you have 2 alpha hydrogen. Here you have no alpha hydrogen. It's C. Here though, no sp3 carbon, no sp3 alpha carbon, so it is not possible. Here, no alpha hydrogen, so not possible. Here you have sp3 hybridized carbon, but here you don't have any alpha hydrogen, so that's why it's not possible here, right? Two conditions, both conditions should be fulfilled. In this case, here on this side, so it's not possible, but what about this side? Here you have sp3 hybridized carbon atom, right? You have 2 alpha hydrogens. You just needed 1 alpha hydrogen. You have 2 alpha hydrogens, guys. So this is definitely possible. Say this is definitely possible. Yes, it is definitely possible. Right? What about this one? This is also sp3. This is also sp3. Here also you have 2. Here also you have 2. Array. This is the best condition. Yes, this is also possible. Right? So here we have 2 cases where tautomerism is possible. In the first case, A and B, it is showing tautomerism. In C and D, it is not showing tautomerism. Right? Okay. Yes. Okay, guys. Got it? Yes, everybody. Let's see where it is showing what you need to do. sp3 hybridized alpha carbon, ma'am. Okay. After that, don't stop there. See whether that sp3 alpha carbon have at least 1 hydrogen or not. If it has, then yes, you can confidently say that yes, it is showing. Otherwise, say no, it will not show tautomerism. Simple case. Okay, got it. Chalo. Next. 1-5 system. I told you, 2 kind of system. I'll also tell you when you need to apply 1-5, when you need to apply 1-3. First, you have to understand what is 1-5. Okay? Chalo. Now, here, let's just firstly mark it from the oxygen, taking it 1 point. What are the numbering? This is 1, this is 2, this is 3, this is 4, this is 5. Right? This is 6, this is 7. I'm not drawing 6, 7 because that is not needed. Right? Now, just write it here. If 1-3 system, very, very important line, is not applicable, if 1-3 system is not applicable because of sp2 carbon, then only you will apply 1-5 system. Then only you will check 1-5 system. Got it? If your 1-3 system, the failure, whenever we fail in some exam, if the reason is that you are, basically the reason is maybe you are not hardworking, right? You had the potential, but you are not that much hardworking. Then you need to check your 1-5 system. That means then you need to work on your hard work and your concentration power, right? If, for example, you don't only understand, you're like, ma'am, I have done a lot of hard work, but I don't understand that. Then there is a doubt, right? For example, you think that, yes, ma'am, I can do this. Ma'am, I can crack JEE if I give my 100% potential, but I have not done this, right? Then you need to even focus more. Same thing is happening here. If the failure of 1,3 system is sp2 carbon atom alpha, है ना? Then check for 1,5 system. Let's see this here. Let's see the example here. Here we can see that, here guys, we can see that what is the reason for the failure. What is the reason for the failure? 1, 2, 3, this is sp2 hybridized. This is sp2 hybridized, right? This is also sp2 hybridized. That means whether you take this as 3 or this as 3, third carbon, that is the alpha carbon, is sp2 hybridized. That is why this is a failure. Now, I will use 1,5 system here. How I will use 1,5 system? Let us check that. Got it now? Why this is a failure? Why I am checking 1,5 system? Why, ma'am? Here, this was a failure, this was a failure. This is a failure because no sp3 hybridized carbon atom. That means because of sp2 carbon atom, it is a failure. But if you check 1, 2, 3, 4, 5, here even fifth carbon is sp2 hybridized. That is why we have not checked 1,5 system here. Right? Here though we will not check only because here it is a failure because of hydrogen atoms. Right? So two conditions. If the condition first will fail, then only check then only check 1,5 system. Now, ma'am, how to do this? This is a very unique way, right? So now let us see that how to do the tautomerism, right? Wait a minute. Chalo. How to do the tautomerism? Firstly, this is 1, this is 2, this is 3, this is 4, this is 5. On fifth, you will have, here also the condition is fifth carbon should be sp3 hybridized and alpha hydrogen present. Right? Condition is same only. Here we were talking about third carbon should be sp3. Here we are talking about fifth carbon should be sp3 and 1 alpha hydrogen should be present. So here you have 2 alpha hydrogens. Right? So what will happen here? What will happen here? This double bond is basically going to shift here. This double bond is going to shift here. Then this will shift here and it will be eliminated. Got it? I am doing that again. Okay. I am doing that again. Double bond is going to shift here at 2, 3 position. Then from 3 to 4 position, it is going to shift here. Basically, from the position where you are picking out this hydrogen, there you need to shift a double bond. So because it is a 1,5 system, very rarely they will ask you 1,5 system. This is the only example they will ask you 1,5. Right? That's why I am telling you this. Double bond shifted here, double bond shifted here, hydrogen shifted there. What you will get? What you will get? Double bond here, it is already present. Here we have shifted new double bond. We have shifted new double bond over here. Here you had oxygen, right? And here hydrogen got shifted here, so it will be OH. So basically, phenol is formed after the 1,5 system. Okay, guys? Phenol is formed after the 1,5 system, after the tautomerism. Okay? Got it or not, everybody? Is that clear? Is that clear, bachcho? Is 1,5 system clear to you or not? Now I am going to give you a simple chart, right? How to understand tautomerism, a simple way. Firstly, what you will see, you will look for alpha carbon, that means third carbon, right? Firstly, you will check two things here, whether it's sp3, two things you will check here, two things you will check. First is whether it is sp3 or it is having any alpha hydrogen or not. This is the third carbon or alpha carbon, you will check whether it's sp3 or alpha hydrogen. If it is, either it will be sp3 or it will not be sp3. Either it will be sp3 or it will not be sp3. Okay? If it is sp3, now the thing is, if it is sp3, then you will check for alpha hydrogen. Okay, let's make another chart here. Firstly, though, you will check for its sp3 hybridization. Hai na? Here only I am writing. Firstly, though, you will check for whether it's sp3 or not. Either it will be sp3 or either it will not be sp3. Either it will be sp3 or it will not be sp3. That means it will be sp2. If it is sp3, then you will check whether it has alpha hydrogen or not. Either it will have alpha hydrogen or it will not have. Either will have alpha hydrogen or no alpha hydrogen. If first condition is fulfilled, that it is sp3 carbon and it has alpha hydrogen, then you will say yes, tautomerism exists. And that is 1,3 system. Okay. If it is not having alpha hydrogen, but it has sp3, then you will say no, tautomerism will not exist. Don't check 1,5 system. Don't check 1,5 system. Don't check 1,5 system, will not be applicable. Right? Okay. Now, in sp2 hybridization, you will check fifth carbon. Right? Either fifth carbon, if it is sp3 hybridized and it has alpha hydrogen, then you will say yes, it is showing tautomerism by 1,5 system. Okay, it is showing tautomerism by 1,5 system. Okay guys, it is showing tautomerism by 1,5 system. Let me know in the comment section if this thing is clear to all of you or not. Right? If this thing is clear to all of you or not. If this is clear, then beta, we will go with the next thing. Okay? Right? Because we have to do the questions also. Right? Okay? Karthik, don't worry. Yes. Chal. Now, here we have nitro, SC nitro. There are different kind of tautomerism that they can show you. The same thing I will apply here. That is 1, 2, 3. Right? So, if you talk about nitro, SC nitro, double bond, single bond and this. Right? What you will do? 1, 2, 3. Same thing you will do here. Same thing you will do here. It will be CH3 here. This is C, this is H, this is H, this is N double bond O, and this is O. Here again you will do the same thing. The double bond from 1 and 2 is going to shift to 2 and 3. So shift this double bond to 2 and 3, to 2 and 3, and shift the hydrogen here to the first place. So it will be like this, which is called your SC nitro. So it is nitro, SC nitro tautomerism. Okay. Next is what they can ask you, nitroso and oxime tautomerism. So here same thing we will do. This is your 1, 2 and 3. Right? Same thing beta, same thing. Same thing we will do here. This is CH3, C, H, H, N double bond O. Shift the double bond from 1 and 2 position to 2 and 3 position. Right? Just shift this to this side. Right? Okay. Then shift the hydrogen to the first position. And that is your oxime. Double bond NOH. That is your oxime. So it is nitroso-oxime tautomerism. Okay. Next. You have imine enamine tautomerism. Here also let's do the same thing. This is 1, 2 and 3. Okay. 1, 2 and 3. Again doing the same thing here. Again doing the same thing. This is CH3, C, H, H, C, H, double bond NH. What I told you, what is the trick? What is the simple method? Double bond of 1 and 2 to 2 and 3. Same thing guys, same thing. Double bond of 1 and 2, right? Double bond of 1 and 2 to 2 and 3, to 2 and 3. Okay, I have shifted it here. I can also put it here, right? So hydrogen of third will be shifted to first position. So remove this hydrogen and shift it to first position. That is going to be your enamine, ene and amine, enamine. Okay, from imine to enamine. Okay, got it? Chal. Next question. Okay, next I think that's it. That was your tautomerism. Now guys, we are going to move forward and we are going to see geometrical isomerism. Right? Okay, then we will start the questions. That will be our first part of this lecture will be completed after that. Right? Okay. If no alpha hydrogen itself, no checking further, isn't it, ma'am? See, if it has failed because of sp3, because of sp2 carbon, then only you will check 1,5 system. If you have sp3 carbon but it does not have any alpha hydrogen, then you don't need to check 1,5 system. Then we will not check it. Okay? Yes, chalo. Beta, this was the thing. Okay, this was the thing that if your third carbon is sp3, then you need to check whether it's alpha hydrogen or not. Then only it will be 1,3 system, and yes, it is tautomerism. If it is sp3 but it does not have any alpha hydrogen, then you will not check 1,5 system. It is definitely a big no, right? It does not show any tautomerism. But if you have alpha carbon as sp2 and the fifth carbon is sp3 and it is having alpha hydrogen, then you will say that yes, it is possible because of 1,5 system. Okay? Yes? Chalo. Now, beta, that was about the structural isomerism. Now let's talk about the stereoisomerism. As you can see here, stereoisomerism, beta, there are basically two types. I'll just tell you one more thing. You can write one more thing which can be asked to you. That structural isomerism are also called constitutional isomerism. Because this is C and C, na, that's why students get confused. Structure are called constitutional isomerism. Okay? Structure are called constitutional isomerism. Then if I talk about stereoisomerism, stereo means when structure is same but the 3D alignment is different. Then you are dancing, you are something like this, like this, like this, like this, right? So that is stereoisomerism, right? Stereoisomerism is basically of two types, okay? First is configurational, other is conformational. Structure was constitutional. Stereo is of two types, configurational, conformational, okay? From here, configurational, we have, it is further divided into two parts. One is geometrical, other is optical. And from these two, a lot of questions are asked, especially the geometrical isomerism. Okay, chalo. Geometrical and optical. And then you have, this is 1, 2. This is the second part is conformational. Here we will talk about mainly alkane and cycloalkane, the conformers of alkane and cycloalkane. Got it? Yes, everybody? Got it? Okay, chalo. Now, we are going to talk about geometrical isomerism, which is a sub-part of stereoisomerism. Okay, so when they ask you to calculate the number of stereoisomer, we will calculate both the things, also geometrical as well as optical isomerism. Okay, chalo. Now, geometrical isomerism. Geometrical isomerism, yeah, very simple. Very, very simple. This is the most sweetest part of this isomerism, right? Even, tautomerism is also very simple. I think now to you feel tautomerism, if you have learned it this way, if you have learned tautomerism this way, you just have to focus on this chart and that's it. You are sorted for tautomerism. This will also become simple for you. Now, I will also make geometrical isomerism very simple for you. How, ma'am? Okay, let's do that. C double bond C. 1, 2, 3, 4. Okay. This kind of, they will ask you the geometrical isomerism. Basically, geometrical isomerism, they will ask you either in cycloalkanes or in alkenes. Okay. Reason is because we need restricted rotation for geometrical isomerism. That means if you have a double bond, we know that a double bond is formed by the sideways overlapping. That is why it has a restricted rotation. If you have a double bond like this, it has a restricted rotation. It can't rotate to a very wide angle. But if you have a single bond, it can rotate to a very wide angle as well. right? Full rotation is possible. That is why double bond and cyclic compound, cycloalkane, will show geometrical isomerism. And in your exam, both the cycloalkane and as well as the alkene, both are asked to you, right? Okay, so first condition is restricted rotation. Second condition I am telling you here, firstly we will talk about alkenes, then we will talk about alkenes, cycloalkenes. Okay, first is alkenes. Mostly alkenes are asked, but sometimes they also ask simple questions from cycloalkenes. Okay, condition is, to this double bond you have 1 2 here, 3 4 here. These are some 2 groups, these are some 2 groups. Geometrical isomerism will only be shown if 1 is not equals to 2, 3 is not equals to 4. Rest doesn't matter to us. If 1 is equals to 4, okay. If 2 is equals to 3, okay. If 1 is equals to 3, okay. If 2 is equals to 4, okay. But what we can't tolerate is 1 should not be equal to 2, 3 should not be equal to 4. That means the groups on the same carbon should be different. Okay, the groups on the same carbon, these groups to be different. On the same carbon, these two groups should be different. Different group on the same side of the carbon. Okay, that is the condition of geometrical isomerism. Okay, now let us see the questions here. Let us see the questions. What kind of questions they can ask you? Okay, so this is A and this is B. Beta, all these are your previous year questions only. Okay, so now geometrical isomerism, right? You need to tell me where it is possible, where it is not possible. Everybody in the comment section, first question that is asked to you based on geometrical isomerism is, which of the following shows geometrical isomerism? For that you need to know which will show geometrical isomerism. Okay, yes, chal. I want to see in the comment section, guys. On the same carbon, 2 same groups. So it will not show geometrical isomerism. Very good, very good, very good entity. On the same carbon, you have same group. So it will also not show geometrical isomerism. Right? Okay. Now, again, this is A, this is B. This is A, this is B. Again, everybody be fast in the comment section, right? Okay, this is your battlefield. Okay, so you have to compete here only. This is very important. Okay, this they will not ask you in the exam. This they will ask you in the exam. Okay, if they ask you this, then anybody can get into IIT. Right? If they ask you this, then only selected can get into, right? And this is not a difficult thing, right? You just have to move step by step, right? This is what I tell you in organic chemistry also, that step by step, GOC, isomerism, naming it, step by step we will go, right? Here also you need to have patience and step by step. Ma'am, step by step, something I am telling you by step by step. See, on this carbon, this is methyl. Me is methyl, okay? This is not helium, beta. This is Me, methyl. Methyl and this is hydrogen, right? So both are different. Ma'am, what about this one? Ma'am, what about this carbon? Ma'am, I don't know, ma'am, some cyclic compound is attached here. Very good. Now, very good, Kirtik. Very good, very good, very good. One by one, we will move. Here move first point, you have this carbon. Here move first point, you have one carbon. Both are same. This is also CH2, this is also CH2. That means same environment we have to see. If I am not getting individual groups, if they have given me some big chain, some big cyclic compound attached to both attached to that carbon, then I will look for the environment. Here also you are getting Chintu. Here also you are getting Chintu. CH2, Chintu. Chintu and Chitu. Here also Chintu is meeting you. Here also Chintu is meeting you. Then one step ahead. Here also CH2. Here also CH2. That means the environment is same. That means this is the same environment on both the sides. So this will not show geometrical isomerism. We want a different environment, okay? We want a different, not the same environment, guys, not the same environment. Okay, what about this one? Methyl and hydrogen to sorted, yaar. Methyl and hydrogen are different. What to worry about that, right? Ma'am, chill pill, ma'am, no worries. What about this one? What about B? Let me see how many of you have. Very good, very good. Veni, Sarvesh, Joseph, Ahaje, very good, very good. Shabash, Kirtik, Shubham, yes. Chintu is your bhaiya, Chintu is also your ma'am. Students call me by Chintu ma'am. Okay, now this is methyl hydrogen, these two are different, okay? What about this carbon here? One step at a time. Firstly, you will go here. You will say, Are, Bintu. Here you are meeting bromine, Bintu. And here you are meeting chlorine, Chintu again, right? So, when you are going to this path, you are meeting bromine. To this path, you are meeting chlorine. So, chlorine and bromine are different, yeah? Right? Chlorine is different, bromine is different. So that's why, that means on changing the path, you are getting a different atom here. That is the reason it has different environment. Different environment. So you will say geometrical isomerism is possible here. Right? Okay. Geometrical. Right? Okay. Geometrical isomerism is possible here. Very good. Understood. Chalo. Now let us do some good questions, right? More questions here. Okay, this is A, this is B, A, and again this is B, again this is B. Guys, understand, only by doing the previous year questions. In chemistry, though, it will not work, right? Because in chemistry, they will also mold the questions, right? In maths and physics, you have a formula, you will solve that. In chemistry, they will give you some new compound. So you have to know the conceptual knowledge should be very good, right? Okay, chalo. Now, here you have this carbon. Methyl and methyl, both are same. We don't even have to look there. You don't have to waste your time in that. Why to waste your time? Here it is same. So GI will not exist. GI will not exist. Okay, it will not exist. Right, beta? It will not exist. Methyl and methyl are different. Right? Okay, what about this one? Hydrogen and methyl are different. Right? Okay, ma'am. But what about this one? Here, when I was going here, I met CH2 and CH2, CH2 and CH2. One step ahead, here I am meeting one bromine. Here I am meeting no bromine. Here I am meeting only CH2. That means different environment I have. Here I have Br, here I have CH2. So I have different environment here. This is also different. So GI will exist. That means geometrical isomerism will be shown here. Okay, geometrical isomerism will be shown here. Very good. Chalo, next. Okay, what about this one? This is a very, very important question, guys. This is worth your JEE. Okay, this is, if they ask you this kind of question, I will say a good paper. Hai na? A good paper they have given you. Because this question also students can solve, right? This is also a good question, okay? Students can solve. But this is an excellent question. This is an excellent question, okay? Chalo. Let's see. Let's see. Very good. Let's see. Very good. Only B, ma'am, both shows some confusion in the comment section. Okay, I'll see. I'll see. Let us see that. Chalo. Firstly, though, we will see this thing because this is simple. This is a little twisted question. Okay. So this is, on this carbon, you have chlorine and bromine. Both are different. Okay, ma'am. Both are different. Here you move one step, you meet CH2. Here you move one step, you meet CH2. Here you move one step more, you meet methyl. Here you move one step, you don't meet any substituent, right? That is why this is also different. So it will show GI. It will show GI. What about this one? Now, what about A, guys? What about A? Everybody in the comment section, A, yes or no? Everybody, if you have yes, just tell me yes or no for A, right? Yes or no for A, right? Okay, chalo. Very good, Ahaje. Very good, very good. Now, very good. This carbon, these two are different. It's sorted, it is different. We don't even need to discuss this, right? What about this carbon? This carbon, when we move one step ahead, you meet CH2. Here also one step ahead, you meet CH2. Understand one point, that when you are moving one step ahead here and one step ahead here, you are coming to the same point. This is the same point. For example, Chintu is standing here, Mintu is standing, Chintu and Bintu, right? Chintu is standing here, Bintu is standing here. I am meeting both of them at the same point. This is the carbon. It is meeting both of them at the same point. If Chintu, it's basically the carbon and bromine are not like this. They are in some different direction, right? It's not like they are on some other carbon only, right? You are getting the same environment. On that same environment, you are meeting both chlorine and bromine. So here the environment is same. Usually students just see chlorine and bromine and mark it the environment is different. The environment is same because you are on the same carbon, right? Okay, so the environment is same here. That is why it will not show any GI. It will not show any GI. Got it, guys? It will not show any GI. Okay, clear, right? Okay, yes, very good, very good. Clear in your head, guys? Clear in your head, right? Okay, perfect. Now next is okay, what about this one? This is a very simple question. Very simple. Very simple, guys. Very simple. Why? This is the carbon. This is the carbon, okay? Here you are moving down, you are getting CH2. You are moving up, you are getting carbon with a double bond. That means the environment is different. The environment is different, okay? Here you are moving up, you are getting carbon with double bond. Moving down, you are getting carbon with single bond. So environment is again different. So it will show GI, right? Okay, yes, it will show GI, right? What about this one? For example, I change this situation to something like this, okay? Chalo. Now, okay, do you tell me about this only? Here, this is the carbon, this is the carbon. On going upwards, you are getting CH2, downwards also CH2. Then you are getting Ca here also you are getting C. Same environment. Here also CH2, CH2, C and C. Same environment. So that means GI will not be shown here. Right? Only A will show the GI. Very good. Very good. Shabash. Now guys, tell me, is there concept clarity? Hai na? Is there concept clarity? If they ask you which of the following will show GI, will not show GI, when I'll solve the previous year question in front of you now, you will get more clarity on this. Right? Okay, you will get more clarity here. Okay, next topic is cis and trans. Cis and trans, cis means sisters. When sisters, tell me guys, if you have any sister, right? If you have any sister, sisters are always sitting together, gossiping about this and that, right? So, sisters are always next to each other, right? So, when two groups are next to each other, that is called cis. When two groups are opposite to each other, that is called trans. That is called trans, right? Okay, like brothers are always fighting with each other. So, they are the trans isomer. Okay, got it? JEE, even I don't know, yaar, what is this duration? I feel that isomerism, if you want to do it in detail, then it will take us like how much time? 1 hour, na? 1 hour, so we have completed cis trans also. I think maybe total 2 hours more, right? Okay, if you include the previous year questions also. Done, beta? So this is your cis and this is the trans, right? Okay, yes. Beta, focus on the topic that I am telling you rather than diverting your mind, hai na? Okay, so this is sisters are sitting next to each other. So this is cis. Cis and trans is the simplest way, simplest thing. Here, CH3. Firstly, identify the same group. See, identify the same group firstly. Why I am telling you to identify the same group? Right, because geometrical isomerism is only possible if you have 1 is not equals to 2, 2 is not equal, 3 is not equals to 4. And under the category of geometrical isomerism, you will see, yes, it shows geometrical isomerism, but what kind? Cis and trans is a type of geometrical isomerism. Either they can exist as cis or trans. The condition is at least two should be same. Okay, at least two should be same, only then they will show cis and trans. Okay, so here these are same, so this is called your trans. Okay, this is called trans. This is called trans. Okay, now next is if all of them are different. If all groups are different, then ma'am, what kind of geometrical isomerism? If you have C double bond C, 1, 2, 3, 4, this is A, or you can say 1, 2, 3, 4 only. This is 1, this is 2, this is 3, this is 4. That means not even a single group. No, we need at least two groups to be same if we want to know whether it's cis or trans. If all the groups are different, there is no two group which are same, then how can you tell that whether this is cis or trans? Do you agree with this or not? Right? That's why we have E and Z configuration. Based on this also, they ask you the questions. Okay? Based on E and Z configuration also, very good questions are asked in your JEE. Right? Really good questions are asked in your JEE. Okay, guys? Got it? Yes, everybody? Really good questions are asked. Okay, very good, Minhaj. Okay. For this, we need to know Kahn in gold pre-log CIP rule. Right? Kahn in gold pre-log CIP rule. Ma'am, what is the CIP rule? Beta, this CIP rule will tell you the priority. Right? Like I told you, the priority chapters. Now, if you have not seen that video where I have told you the priority chapters of JEE that you need to do for physics, chemistry and maths, then you need to watch that, right? And I have also posted a short, right? You will see on the YouTube short section of this channel, chemistry topics that you need to do, right? If you want to get 99 percentile in chemistry, right? Then you can't skip those topics, right? So I have already given you the priority here. Right? Oi, hoi, who is this entity? My old student. That's why he is telling that E is enemy. Hai na? Very good. So, here we are going to talk about the priority. As my old students already told you, E is enemy. Right? E for enemy, right guys? E for enemy. Chalo. Ma'am, E for enemy, ma'am, what do you mean by that? I'll tell you. Just give me a minute. Right? Firstly, though, how to apply CIP rule. Right? To apply CIP rule, you need to understand few things here. First is to prioritize things. 1, 2, 3, 4. What is the priority? So on each carbon, we will set the priority as 1, 2. For example, the priority is, on this, the priority is coming out to be 1, 1 and 2. Sorry, 1, 1 nahi. 1, 2, 2, 1. Or the priority is coming out to be 1, 2, 1, 2. Now, if the same priority group, I'm not saying the same group, I am saying the same priority, right? Same priority means if 1 and 1 are on the opposite side, that is called E. Opposite, who is opposite to you? Enemies are opposite, na? Enemies are opposite. Or your friends are opposite to you. Enemies are opposite, right? So, when the same priority is opposite, that is called E. When the same priority is on the same side, same, Suzanne, I'm saying. Okay. So, basically, I don't know, love for Hrithik Roshan, guys. Okay. So, this is 1 and 1. So, that is Z. Okay. Got it? Chalo. So, now E is the when you have opposite side. Z is when you have the same priority on the same side, right? Now, the next question that will arise in your head is, ma'am, how to understand the priority? Ma'am, how to understand the priority? And this rule will be applied while doing RS configuration also. Understand this rule, very, very simple rule, okay? So, the rule says that, let me see if I have written that rule. No. So, I'll just write this rule here. Rule says that priority will be according to the atomic number. More is the atomic number, more is the priority. That means hydrogen, which is having the least atomic number, is always the lowest priority group. Okay, more the atomic number, highest priority. Fluorine, and if you compare fluorine and hydrogen, which will have more priority? This is having more atomic number, so it is having the first priority. This will have the second priority. Okay, so that is how it is done. Now, if you have isotopes, ma'am, here too you're talking about atomic number. What if we are what if they have given us T and D? What is they have given us T and D? Now, how to tell the priority? So, priority is more the atomic mass, more the atomic mass, more is the priority. In the isotope, we know that there is difference of atomic masses. So as the atomic mass will be more, that will have the high priority. Okay, got it? Yes, everybody. Okay. Chalo. Now, here let us solve some questions here. Okay, chalo. Beta, I don't want any of you who are chit-chatting here na. When I'll solve the previous year question, then you will say, ma'am, please, ma'am, please, ma'am, please, ma'am. What was the concept, ma'am? Beta, that's why I'm telling you the concept, so that we can do the previous year questions. Not just, ma'am, you solve the previous year question, I'll just look at you. Beta, I am to thodi going to solve the previous year question in the exam. In the exam, to you will solve the questions, right? So, that's why concept firstly, previous year question lately, right? Okay, chal. Now, here you have, firstly on one side you will see the priority. And again, one by one. What do you mean by one by one? You will not look at NH2, ma'am, the atomic mass of NH2. No, you will look at only the atom that is directly attached. Here the directly attached atom is nitrogen. Here the directly attached atom is hydrogen. So here you will say that this nitrogen is basically having what and hydrogen is having what? Hydrogen is having atomic mass priority 2, because this is having lower atomic number. This is having nitrogen is having more atomic number. This will be 1 priority. What about this one? Here the directly attached atom is carbon, and here you have chlorine. Chlorine is having more atomic number, so it will have first priority. This will have the second priority. So you can see that the same are on the same side. So this is your Z configuration. Okay, this is Z configuration. Okay, got it? Chalo. Next question here. Next question here. Here, this is very important. Okay, chalo. First carbon is C. This is also C. Wait a minute, I'll just draw it like this. CH2 it is. I'll tell you how we need to draw it to get more concept clarity. This is H, H and H. This is H, H. This is C, H, H and H. Okay, ma'am, what you need to do here? Right? Okay, let's see what we need to do here. Why I have expanded this. The first atom that you will see here is carbon. This is also carbon. Both are same. Now we will see this carbon is connected to 2 hydrogen. This is also connected to 2 hydrogen. So just eliminate the common things. Eliminate the common things, okay? Eliminate the common things, guys. Hydrogen is common, so just eliminate that thing. Okay, hydrogen, 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 cancel. Carbon, carbon was also common, so cancel. This carbon was connected to a different, we need to find the thing which is different, right? The first differentiating factor that I can see is here it is connected to carbon, here it is connected to hydrogen. So here I will see the priority of this carbon and this hydrogen, okay? The priority of this carbon and this hydrogen, right? Okay? Okay, got it? Chalo. Now, here you have carbon and this is hydrogen. That is why this is having second priority, this is having the first priority. Okay, what about this one? This is having the second priority, this is having the first priority, second priority here, and this is the first priority. What about this one? This is Cl and this is hydrogen. Hydrogen is having the second priority, Cl is having the first priority. 1, 1, 2, 2. It is 1, 1, 2, 2. That means on the same side. So answer is Z configuration. Okay, answer is Z configuration. Okay. What about this question? Hanji? This carbon is connected to hydrogen. This carbon is connected to tritium. Right? Here we know that this is having more atomic mass. More is the atomic mass, higher is the priority. So the priority is 1, here priority is 2. Okay. Okay, what about this one? What about this case? Here you have carbon. Okay, I'll just eliminate these two hydrogen. It's not eliminated, I'm just drawing it in a different way. Right? Okay. So basically, this is going to be 1H here, 1H here, 1H here, and 1H here. Okay. Now, what you need to see here? Now, beta, what you need to see here? This carbon is connected to this carbon and this carbon. Both are same only, so cancel it. It is connected to hydrogen and this hydrogen, both are same. This hydrogen and this hydrogen, both are same. What is the differentiating factor that I can see here is oxygen 18 and oxygen 16. Okay, oxygen 18 and oxygen 16. So oxygen 18 has more atomic number, so that is why this will have first priority, this will have second priority. So answer is 2, 1 and 1, 2. That means opposite. So answer will be E is the correct answer. Okay, E is the correct answer. Got it or not? Right? Okay. Okay. Chal. Now, next we have beta. These are two different groups. Why it's not a geometrical isomer? These are the isotopes. Okay, when the isotopes are different, right? That means the group is different. Right? Okay. Chal. What about this one? What about this one, guys? What about this one? This is a very, very important question. Okay. Okay, everybody. What about this one? Chalo. What about this one? This is a good question. If you're able to solve this, you will be able to solve the JEE questions. Okay. So here, remember one thing about CIP rule, that triple bond is considered as 3 bonds. That means 1 bond, 2 bond and 3 bond. If you have C triple bond C, it will be considered as C, C and C. 3 bonds with carbon. If you have double bond with oxygen, that will be considered as 2 bonds with oxygen. Okay. Okay, this is to make the question easy for you. Right? Okay. Now, this triple bond means, I'm just going to draw it, redraw this, and we will see that how we can identify what is happening. This triple bond can be considered as, 1 carbon, 2 carbon, 3 carbon. This double bond will be considered as, wait a minute, this double bond will be considered as 1 hydrogen was already present. This was CH. Double bond means 2 carbons here. Right? Okay. Chalo. This double bond oxygen means we can say that this is nothing but 2 carbons, 2 oxygens. This means that this is the same only. This means that we'll just draw here CH2, right? We'll just draw here CH2, right? So this is 1 hydrogen and 1 hydrogen. Okay. So now we will solve everything. Right? Hypothetically, we will imagine that. So if you talk about this carbon, the carbon that you can find after this, when you move one step ahead, carbon and carbon are same. So cancel them. This carbon is connected to 1 carbon. It is also connected to 1 carbon. Cancel this. This carbon is connected to 1 more carbon. This is also connected to 1 more carbon. So cancel this. Same will be cancelled. The differentiating factor is it is having hydrogen, it is having carbon. This is different, so it will not be cancelled. Okay. So which is having the more priority? This is having more priority and this is having less priority. Okay. Coming to this side. Coming to this side. This carbon is connected to one carbon, both of them are same, so it is cancelled. This is connected to one oxygen and this is also connected to one oxygen, so this oxygen and this oxygen is cancelled. This is connected to one hydrogen, this is also connected to one hydrogen, so hydrogens are cancelled. So this carbon has a differentiating factor, that is this oxygen here and that is this hydrogen here. Right, we know that oxygen has more priority, so it will be 1, it will be 2, so answer will be 1 and 1. Here it will be 2 and 2, so answer will be Z is the correct answer. Okay, yes, okay. Okay guys, got it or not? Chalo, got it? Yes, everybody in the comment section, got it or not? Understood? So how we are going to solve this? Okay, this is the best method, guys. This is the best method of solving, right? Just by cramming that double bond has more priority, triple bond has less priority, you will forget everything, right, in the exam, right? So that's why this is the best method. Just imagine that double bond means 2 bonds, triple bonds, and it's not, I am not saying this, this is actually written in the books. Okay, that's a proper method. Okay, yes, I am not making this myself. Okay, this is my trick. Okay, so this is actually a method. Okay, CIP method, right? Okay, chalo. Now EZ system to beta we have done. Now let us talk about these two things, that is anti and syn. Okay, anti and syn. Ma'am, what is anti and syn? Anybody in the comment section? Anti and syn. Anti and syn. So if you talk about here, we know that here oxygen and hydrogen will be taken out and you will have the formation of aldoxime and ketoxime. Okay, so when it is formed from aldehyde, beta, basically here you have the formation of oxime. Oxime is what? C double bond N OH, right? If it is formed from aldehyde, that is called aldoxime, right? This is from aldehyde, this is called aldoxime. If it is formed from ketone, that is called ketoxime. Okay, ma'am, why you are telling all this to us, right? So I'll tell you why I'm telling you this. They can ask you anti and syn also. Dekho, they have asked cis trans, EZ. They can also ask anti and syn. Very simple thing. Okay, anti and syn means, if you talk about aldoxymes, it is easy. In aldoxymes, it's very easy to understand what is anti and what is syn. Okay, so here what you will see that when H, this is basically H and OH are on the same side. Okay, H and OH are on the same side, that is called syn. If H and OH are on the opposite side, that is called anti. Okay, if H and OH are on the same side, that is called syn. If H and OH are on the opposite side, that is called anti. Anti means opposite. Okay, if something is on the opposite, same group, same side, syn. Very good. Okay, so H and OH on the same side, syn, anti, opposite is anti, right? Okay. Ma'am, what about ketoxime? Ma'am, here too we don't have hydrogen. Then how we will compare OH with what? Then this can have two things. Okay, it can also have anti and it can also be syn. Depends on what you are naming it. If you are comparing this with ethyl, for example, if I am comparing with this the opposite group that is present directly, not opposite, the same side group, then it will be called syn. First thing you will write is ethyl. Ethyl, methyl, ketoxime, right? But if you are comparing this with the opposite group, then you will write anti. And what is anti? Methyl. Anti-methyl, then you have ethyl ketoxime. ethyl ketoxime. Okay, got it? Yes, beta. Chalo. Done. Now let us see cycloalkane. How they can ask you geometrical isomers in cyclohexane. Okay. In cyclohexane, what kind of question they can ask you? They will not ask you cis on trans. They will ask you whether it will show GI or not. Okay. Okay. Minhaj, please ask the doubt again. Man, you will bring practical chemistry. Definitely, I'll bring practical chemistry. Don't worry about that. Right? Okay? Chal. Okay, guys, tell me one thing. Shall we start with cyclohexane? Very short topic it is. Okay? You just have to do this thing. It's like you have something which is very broad. For example, you have a paper. Wait a minute, I'll just pick out one paper from here. For example, you have something which is like this. Okay, something which is like this. Okay, so you need to do just one thing in cyclohexane, cycloalkane. Just need to press it. Okay, this is what you need to do. Okay, this is what you need to do. Ma'am, what do you mean by this? What was this, ma'am? What is paper folding, ma'am? We will do paper folding in the exam. Yes, you will imagine it like that. Okay, so basically there are two methods to solve this. Firstly, that is the original thing. That is, you just think that, just hypothetically assume that, just press this thing and it will be a double bond. So consider it as C double bond C, CH3, CH3. Now solve this. We know that here we will have one hydrogen. We know that on one carbon both are opposite. On one carbon both are opposite. Right? Okay. Then we will say it will show GI. This is the first method that I am telling you. I'll also tell you the shortcut here. Okay. I'll also tell you, ma'am, all are. Chalo. Now, here also we'll do the same thing. Just compress it here and you will have double bond, and this is CH3 and this is CH3. Just think about this as a double bond. Think about, just erase this and think about this as a double bond. This is what I am asking you to do. Right? Okay. Got it or not? Here, this is the imagination that you have to do. Now, this is H, this is H. Now, rotate it. This will be double bond. This is CH3. On one carbon, you have CH3 and hydrogen. On other carbon, you have CH3 and hydrogen. CH3 and hydrogen. So, both are opposite. Then you can say this is also showing GI. This is the first thing that you can do. Ma'am, please tell us the shortcut. Write the shortcut, write it here. The shortcut is same group on same carbon, no GI. Otherwise, it will show. If you have even a single carbon which is having the same substituents, right, then it will not show GI, right? For example, I say that here you have CH3 also. Then compress this thing here, you will have a double bond, you will have a CH3, you will have a CH3, you will have CH3, and this is H. Same group on same side, that is why it is not showing the GI. Got it? Okay? Are beta, okay or not? Hanji, everybody. Hanji, everybody. Okay, beta. Okay, yes. Huh? I am not saying cis and trans here. I am not writing anywhere cis and trans. I am saying that this is showing GI, right? I am not saying this is cis and trans. Cis and trans you can't predict if you don't know the exact arrangement there. Whether it's outwards, inwards, what is the configuration, exact configuration. I'm just telling you which is showing GI, which is not showing GI. Okay, chalo. Now, same thing we will apply here, right? On this cycloalkane, do you have any carbon which is having the same substituents? See, do you have any carbon? Now students will say, yes ma'am. Here you have hydrogen ma'am, 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 hydrogen. But I am not even considering that carbon which is not having any substituent. Here, when I am giving you this short trick, I am only talking about those carbons which on which there is some substituent attached, right? On which there is some substituent attached. I'm only talking about those carbons. So here, let's not talk about the hydrogens here. This carbon and this carbon, right? It has chlorine, it has a bromine, right? So that means both of them are different. This carbon has only one substituent, this also a bromine. That is why it will show GI, right? What about this one? Here also students will do the same thing. They'll be like, ma'am, squeeze this thing, ma'am, on the same carbon, this and that. Array. Double bond already they are giving you. This is basically a double bond here. Then you have 1, 2, 1, 2, 3, 4. 3, 1, 2, 3, 4. है ना? 1, 2, wait a minute. 3, 4. This kind of 1, 2, 3, 4. And on this you have chlorine. On this you have bromine. Right? So already you have double bond. I am talking about cycloalkane. In case of cycloalkene, I am talking about this thing. This is the same thing that we talked about. Now, here you are getting CH2 and Cl. Here you are getting CH2 and Br. So both of them are different only. So that is why GI will be shown here. Right? GI beta will be shown here. Because upwards on this carbon, you have one CH2 and downwards you have Cl. So the environment is, the groups are different, right? Here also the groups are different. So it will show GI. Okay? Okay? Got it? Chalo. Got it, guys? Right? Okay? Oh, yeah. No, it's so alkene. It will not show any. This will not show GI because it has restricted rotation. Very good, yeah, very good. It will not show GI because of restricted rotation. That I forgot only. Because of restricted rotation, it will not show any GI because alkenes. Wait a minute. अरे नहीं. Restricted rotation we need here. It will show GI, yaar. It will show GI. It will show GI. Mark it, yes. It will show GI. Kritik is next level. Kritik, it will show GI. Restricted rotation is the condition of GI. Restricted rotation is the condition of GI. So it will show GI. Right? Okay? Done. Because here upwards you have different environment. Downwards you have different. Upward different. Downward different. Okay? Right? Okay? Arey yaar, what's your doubt? Again type it. So it should. Wait a minute. This is the question that I drew myself only. Ma'am, I said if you fold alkyne forms, thus it will not. You don't have to fold it here. Here it will not be like a folded thing, right? That I was telling you only about the cycloalkane, okay? That was only about the cycloalkane, not about cycloalkene, okay? Wait a minute. Wait a minute, total number that, wait a minute. There was some comment that I was looking for. But restricted rotation is required, no? No GI due to restrictions in rotation. There is a question, if both OS 16 will not show geometrical. Yes, Minhaj, if both are oxygen 16, then it will not show. Okay, in that case, it will not show. Achha, what about this? What about this question here? No, I'm same environment after CH2. But I am not talking about this is a different carbon, this is a different carbon. I am talking about on this carbon, right? You have CH2 here, right? Downwards you have Cl. On this carbon, this is the CH2, this is the Br. Okay, so I am not talking about. See, you are getting confused between if you have C double bond C, here you have some group, right? This is Cl, this is Br. These two are different questions, okay? Here I am talking about go upwards, this is CH2, this is CH2, this is CH2, this is CH2. Same environment on same carbon. Here I am not talking about same, here though it is different environment only. Na? This is CH2, this is Br, this is CH2, this is Cl. Huh? This is CH2, this is Cl, this is CH2, this is Br. So the environment is different, right? Okay. That I have to check. Okay, then make it as a question, right? That I have to check. Okay, others for me, so it should show GI, but as you are making it a question, right? Then I'll tell you the answer after the break. Okay, by full confirmation, right? Because the point that you are putting is regarding the angle restrictions. Okay, so angle restriction, so that is a different concept only, right? Okay, chal. But otherwise, if you talk about without angle restriction, if you talk about only the environment, then to it will show. Okay, got it? Chalo. Now, next is this one. Now, if you talk about this cycloalkane, in this cycloalkane, you have methyl and this is also methyl, right? That means on the same carbon, you have two methyl group. So if on the same carbon you have two methyl group, that means it will not show GI. Okay, it will not show GI. Okay, chalo. Now we are going to number of GI, so we will not calculate now. Now we will move towards the questions based on structural and geometrical isomerism. Okay, let's do the questions. What kind of questions they ask you? First question, as you can see on your screen, is first question is, which of the following compound will not undergo tautomerism? Okay, which will not undergo tautomerism? Tautomerism means you should have alpha carbon as sp3 and alpha hydrogen should be there, right? Okay, so if you talk about this form, it can directly get into the keto form. It will get into the keto form, right? So what kind of form it will form? This will be shifted here, this double bond will be shifted here, so it will get to the keto form. Double bond is shifted here, hydrogen is shifted here, so it will get to the keto form. If you talk about this carbon here, right, this is having alpha, this is also alpha, this is alpha and this is alpha. This alpha is sp3, this is also sp3, this is having two hydrogens here, this is having one hydrogen here, so it will also show tautomerism. What about this one? This is sp3, this is sp3, this is also having one hydrogen, this is also having one hydrogen. Again, it will show tautomerism. Here it is having sp3 and sp3, but no alpha hydrogen, so it will not show tautomerism. So answer is going to be D is the correct answer, which will not show tautomerism. Very good. D is the correct answer. Next question on your screen is, if you have how many minimum number of carbon atoms are required for position, and geometrical isomerism in alkene. Okay, so how many number of number of carbon atoms are required for position and geometrical isomerism in alkenes? Okay, if you talk about alkene, if you talk about this alkene, can it show geometrical isomerism? Not possible. It will not also show position isomerism. Position means the double bond should change the position, right? This will not show geometrical, this will not show position, right? What about if you have 3 carbons? Double bond here, this is CH, 1, 2, 3, 4. This is CH, this is CH2. If double bond is shifted to this side, see, if you talk about the geometrical isomerism, then you have 2 hydrogens here. This is 1 hydrogen, this is 1 CH3. Now again on the same side you have same group. So it will also not show GI. It will also not show GI. What about position? If the position changed from this position to this position, that is the same compound only. So position isomer also will not be shown here. Right? Okay. So 3, 3 is not possible. 3, 4 is not possible. 4, 3 is not possible. Because in 3 carbons, it's not possible only. What about 4? If you have 4, 1, 2, 3, 4. So in 4, it can show position because double bond can be shifted here. Double bond can be present here. This is a different compound. This is a different compound. Right? So that is the reason 2 compounds can be formed of position isomer. Ma'am, what about geometrical isomerism? What about geometrical isomerism? If you talk about the geometrical isomerism, C double bond C, you have H, you have CH3, you have H, you have CH3. This is nothing but GI only 1, 2, 3, 4. Right? It is having 1 double bond, 4 carbons you have, and it is showing geometrical isomerism here. So answer is B is the correct answer. 4 you need to have carbon if you want to show position or geometrical isomerism. Okay, yes, the concept of structure and geometrical isomerism is over. Okay, yes, now let us see the concepts now. Let us see the questions now. So here, next question on your screen is, the E isomer among the following is, they are asking you the E isomer. E isomer. E isomer, guys. Okay. So we need to see the priority here, right? This is the carbon, here the carbon, and here you have chlorine. So it will have first priority, it will have second priority. Again, this is bromine and this is carbon. It will have second, this will have first and this will have second priority. So here 1, 1 and 2, 2. That means it is Z, right? What about this one? Here you have chlorine and carbon. So this is first priority, this is second priority. Carbon and carbon. So that means we need to see the other things here, right? So what we will see here? We will see here C2H5 now. So let's draw it like this, C double bond O. What is C double bond O? That is CO and O, and this is H. Here it was CHO, na? So I have drawn it in a different way so that to make it easy for me. This is CH2OH. So this is H, this is H, this is again CH, H and H. Now I'll cancel things. This carbon will be cancelled. This hydrogen and this hydrogen will be cancelled. The next step that they have common is this oxygen. It is having 1 oxygen and this is having 1 carbon. This is having 1 hydrogen and this is having 1 oxygen. Clearly, we can see that oxygen is having more priority here, right? So here we can say that this is the first one and this is the second one. So definitely opposite, 2 and 2. So that is why it is going to be E. So answer, so we know that the answer is B is the correct answer. Okay. Okay. This is not a geometrical isomer. This is not even a geometrical isomer. Okay. This is a trans isomer. This is a trans isomer. Okay. Got it? Chal. Okay. next question on your screen, guys. What is the metamer? What is the metamer? Who is the spammer? Yeah, I can to only see the students. Which is the metamer of the compound? Metamer, okay? Now the question is on metamerism, right? Metamer means you have, or the two bridges should be different, okay? So this bridge is O. Methyl should not be present here. The compound should be same. This is methyl and here also you have methyl, right? So this will not be the answer. This is also OMe, that is also OMe, that is not the answer. This is also OMe, that is also OMe, that is not the answer. Better, the questions are very simple, okay? So this is CH3, CH3, here you have methyl, here you have ethyl. Here you have a benzene where CH3 was linked. Here you have only the benzene ring, phenyl ring. So this is going to be the correct answer because the rings, the side chains are different now. So answer will be D is the correct answer, okay? Your previous year questions only, beta, they are. Okay? Chalo. Next is geometrical isomerism is possible in. Geometrical isomerism is possible in which case? GI is possible in which case? Right? Okay? Now, geometrical isomerism is possible in which case? Yes, beta. Very good. D, 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 D. Is it? Okay. Geometrical isomerism is possible in which case? If you see this here, now I got your answer, na? Yes. So we got our answer here only, right? Yes. Now I knew what you were talking about. So let me just mark it correct there. Where we were at this point. Oh my God, how much we have to deal with. Huh. This is not possible, right? That was right. Very good, Shubham. That was right because less than 8 will not show. Less than 8 will not show. Okay, less than 8 will not show the geometrical isomerism. Okay, acha. The question was, where was the question, yaar? Okay. Now, geometrical isomerism is possible in which case? This is less than 8. This is less than 8. This is less than 8. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it is possible here. Answer will be D. Okay. Answer will be D. Chalo. Now, next question is, which of the following is correct set? Which of the following correct set of physical properties of the geometrical isomerism? Okay. Properties they are telling you. First thing is, guys, this is trans, right? And this is cis. Okay, this is cis. So now you have to answer some statements regarding cis and trans, right? So this I have already done in alkenes and alkynes, hydrocarbons. We have already done that. Dipole moment of trans is more than cis. Okay. Boiling point is also trans is more than cis. Melting point is also trans is more than cis. Right? Okay. Then you have which thing? Wait a minute. Melting point, stability. Okay. Stability of trans is also more than cis. So where I can say everything is more. 1. So this is eliminated. This is eliminated. 1. Okay. This is also eliminated. Answer will be C. Okay. Answer will be C. Okay. Chal. Next is, how many alkanes are possible with molecular formula this? How many alkenes are possible? So this is CnH2n, right? How many alkenes are possible with this? So if you talk about this thing here, right? First alkene that is possible is double bond over here. Second alkene that is possible is double bond over here. Right? Okay. CH2, right? This is 1. CH2, CH3, CH3, CH, H, CH3. Right? So, first is these two alkenes, then you have any cyclic is not possible, right? So only possibility is other alkenes are also not possible. How many alkenes? So answer will be, is my voice not audible? Guys, is my voice not audible? Just let me check. Hello, hello. You're audible to hai. It is audible, yeah. Okay, chal. With the molecular formula CnH2n, right? So this is one alkene, two alkenes. Cyclic is not possible. Other alkene is any other alkene possible with this particular formula. Formula should be this thing only, right? Any branching is possible. Any branching, if you talk about any branching, if you have this kind of alkene, this branching is possible. CH3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 2, 6, 7, 8. है ना? This branching is possible. 3 we have till now. ठीक है? 3 we have till now. Any other branching is possible here? 4th we have, 3 we have, 2 is not possible. Right? Then we'll get 1 only. Right? Okay. So what is the 4th isomer you're talking about? That too I have taken. I think 3 should be the correct answer. 4. Wait a minute. What is the other possibility here? If we put, how many alkenes they are saying, no? So 1 alkene, 2 alkene. Okay, 4 carbons we need to have. But they are not asking you about geometrical isomerism, okay? They are not asking you anything regarding GI, right? This is a simple thing. How many alkenes they are saying, na? Cycloalkane is not an alkene, okay? Cycloalkane is not an alkene. Cycloalkane is this, okay? If you talk about cycloalkane, butane, that will be this thing, right? So that is CnH2n. But something else can be possible. If you have something like this, let me see. If you have something like this and you have a double bond here, not possible. Cyclic square, they are asking how many alkenes are possible. That is cycloalkanes, guys. Cyclic square is not alkene. Any other isomer that is possible. I'm not. Any other isomer. Okay, let's draw this thing here. Branching, though, only this is possible. Out of branching, 3, 4, 5, 6, 7, 8, right? 2, 3, 4. Ma'am, in first case, substituent CH3. Acha, 1 means possible. Beta, cyclic is not, they are not asking about cyclic, guys. Firstly, so cyclobutene is not possible, right? The thing they are saying is this thing, okay? They are talking about this thing, HCH3 and HCH3. This is what they are talking about, okay? Na, not cyclic, not optical. Dekho. That's what I was thinking. Because cyclic butane is CnH2n, but they are talking about alkenes. Okay. So cyclic butane is not it is the isomer, but it is not a alkene. Okay, it is not a alkene. So cyclic alkane is not considered here. Okay. Second thing is you're talking about cyclic butene. Cyclic butene will not have this formula. This will be double bond. This will have CH2. This will have CH. This will be CH. This will be CH2. It will be 2, 3, 4, 5, 6. It will be C4H6. So that is also not the correct thing. Right? So cyclic butane is not the fourth alkene that we are talking about here. Right? So basically it is double bond here or double bond present here. Right? Then what you can have, okay, then basically we are talking about cis and trans only, right? The different geometrical isomers that we can have. Okay, different basically orientations that they can have, right? So either they can have cis orientation or they can have trans orientation, or here they can have ethyl here and H here, right? Different orientation that we have. Okay. Okay. Ma'am, alkene has isomer. Beta, they are not asking you the isomer. How many alkenes they are asking you? Alkenes. Right? Okay? Alkenes they are asking you. Right? Okay? Chalo. Now, if they are considering, but the problem is that this and this is the same thing. Right? This is CH. I am just dividing this thing into two parts. This is the cis isomer. This is not even the cis isomer. Acha. Okay. 2, 3 things are possible. Wait a minute. Let me just draw the double bond here. How we can draw it. Okay. Acha. One is this isomer. Other is the trans isomer. Trans isomer is CH3 here. CH3 here. H here and H here. These are the 4 isomers that it will have. 1, 2, 3 and 4. Okay, these are the 4 isomers that it will have. Right? So first is going to be, beta, this is not the same. Right? Let me just draw it here. C double bond C. This is CH3. This is CH3. This is H. Beta, they are not asking you the geometrical, they are not asking you the isomer, they are asking you alkenes, simply alkenes. Okay, so here I have put double bond here, right? That is the first alkene that can exist. The second alkene that can exist is on the center, but CH3 on the same carbon. Third alkene that can exist is that they should be on the opposite side. So we know that here geometrical isomer will exist. So either trans can exist or cis can exist. So totally 4 will exist here. Right? Okay? Okay, beta? Understood? Chalo, so answer will be 4. Okay? Answer will be 4. Chalo. Okay, these are the 4 isomers that will exist. Answer will be 4 is the correct answer. Chalo. Next is, bacha, you also need to see that the formula should be CnH2n only. In cyclobutene, if you form the cyclobutene, here they are asking the number of isomers having C4H8. See, the question is different. Here, how many alkenes are possible of this formula? Here they are asking you how many isomers. Now the approach will be different, right? There we are not talking about any other thing. Now here they are asking you how many isomer. Isomer, so you can make cyclobutane is also the isomer, right? Okay. So here the answer will be how many isomer having molecular formula C4H8 is possible, right? So isomer is, first thing is your cyclobutane, right? Okay, that is the first isomer. Other isomer is this C double bond, this thing. Okay, this is the second isomer that you will have when you have the double bond here, right? Okay, the third isomer that you can have, wait a minute, one more, this is butane. This is also CH2, 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 CH2. 2, 3, 4, 5, 6, 7, 8. Okay, if you draw this thing here, CH, CH2, CH. I'm just drawing it to see 3, 4, 5, 6, 7, 8. है ना? This is also possible. 1, 2 and 4 that we have drawn here. 4 that we have drawn here, that is possible. These are also the isomers. Plus these cyclic also. These two plus these two cyclics. That means 4 plus these two cyclics. So I think 6 should be the answer. Okay? Got it? Got it, guys? There we were seeing only the how many alkenes. Here we will see also the how many isomers are possible. So I just need to see the molecular formula should be same. So molecular formula is same in these two cases also. Right? Okay. So answer will be D. Chalo. Next is, which of the following pairs of compound are functional isomers? Okay. Functional isomers. Functional isomers, guys. That means the functional group should be different, right? So this is COO only. This is COO. So functional group is same only. So this is not possible. This is COO. This is CO. CH2. Then you have O. Right? That means the functional group has changed. One ketone and one ether. So this is the functional isomer. Right? Here also OH. Here you have ketonic, two ketonic groups here. Right? So answer is B is the correct answer. Next is, which of the following compounds is isomeric with methyl vinyl ether? Okay, methyl vinyl ether. Ether means you will have O here. Methyl means CH3 will be present here. Vinyl means to this thing you will have one vinylic group, that is CH. This is the compound. Now you just need to calculate the carbon here. This is C3H1 3 4 5 6 and one oxygen, right? C3 3 4 5 6 and one oxygen. Okay. So I need to see which of the following has this particular formula. We know that propanol is having which formula? 1 2 3, right? 1 2 3 propanol. That means double bond O. This is H, this is CH2, this is CH3. 3 4 5 6, 1 oxygen, 3 carbon. So definitely propanol is the correct answer. Right? First is only the correct answer. We don't even need to check the other things, right? Okay. Okay. If you want to check, you can see that ethyl, methyl, ether, right? 1 propanol, right? Okay. So answer will be, wait a minute. Why B? Propanol means OH. This is CH3. This is CH3. This is CH. 3, 4, 5, 6, 7, 8, beta. Here, though, we have just 6 hydrogens. Isomeric, beta, isomeric. Are you telling me the last answer? है ना? Last answer you are telling me. अच्छा. What about this one? What about this one? What about this one? This is C3H6O only. The formula is same. So they are isomer of each other. So answer is A is the correct answer. Okay? Got it? Chalo. Next we have 2-butyne and 1,3-butadiene are. 2-butyne. That means 2-butyne, 1, 2, 3, 4. 2-butyne means this. 1,3-butadiene. 1 and third position you have butadiene. So this is CH3. We know that these are position isomers. Okay. So H, H3, CH2. This is H, right? H, CH2. 2, 3, 4, 5, 6, 3, 4, 5. Wait a minute. Here it should be 1, 2, 3, 4. 1, 2, 3, 4. Position isomer. How come their hydrogens are not coming out to be equal? 2, 3, 4, 5, right? And this is, acha, ine hai na, it is. That's why. Not position isomers, guys. These are not position isomers by mistake. Right? This is CH3. 3, 4, 5, 6 and now this is same. Now this is ine and this is 2 enes, right? So basically the functional group is different, right? So it is going to be functional isomerism, okay? Functional isomerism. Next is the functional isomer of ethers. A very simple question. Ether, ROR dash is basically R double dash OH. That means alcohol is going to be the function. Very good. C is the correct answer. Very good. Next is tautomerism is not exhibited by which of the following? Tautomerism, guys. Tautomerism is not exhibited by which of the following? Which does not exhibit tautomerism? Tautomerism means sp3 hybridized alpha carbon. So this is your firstly, if you talk about this thing here, double bond can shift here and hydrogen can shift here. So it will be like this. So tautomerism is present here. This is the tautomerism is present. Okay. What about this one? To this ketonic group, this is sp2, 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 sp2. It's not possible. So definitely on B, it is not possible. Here it is possible because of this alpha carbon which is having two hydrogens, right? Here it is possible because of this alpha hydrogen and because of this alpha hydrogen which is sp3 hybridized and it has two hydrogens also. So which will not exhibit is B is the correct answer, okay? B is the correct answer, okay? Chalo, next. Which of the following compounds can exhibit tautomerism? Dekho beta, same question they are asking again. Can exhibit, cannot exhibit, right? Same, based on same simple concept, right? Which of the following can exhibit tautomerism? Which will exhibit tautomerism, okay? So this is phenyl, right? Or you can say double bond, C double bond O, and this is H. It has only one alpha carbon which is sp2, right? Then you will say, ma'am, if this is sp2, can we see the 5 system? 1, 2, 3, 4, 5. Fifth is also sp2. So it will not exhibit tautomerism. They are asking you which will exhibit. This is basically Me means, what do you mean by Me3? Me3 means we are talking about that it will have 3 methyl groups here, right? 3 methyl groups means something like this, okay? One CH3, other CH3 and this CH3. Now beta, this is the alpha carbon and this is the alpha carbon here. If you see that, ma'am, what do you mean by this C6H5? That is nothing but this is the benzene ring over here, right? Benzene ring over here, okay? Okay, so this is sp2, others are also sp2. By this, so it is not possible. This is alpha, but it does not have any alpha hydrogen, so this is also not possible. Answer is not possible. What about this one? Here, this is benzene, not possible. This is COH. Here, it does not have any alpha carbon only, so not possible. But this is alpha carbon and it has 2 hydrogens, so this is possible. By this thing, it is possible. Tautomerism is possible. What about this one? Again, benzene here, not possible, right? So answer will be only in C it is possible, okay? Okay, very good. Only in C it is possible. Chalo, next is, now they are asking that which is position, chain, function or metamers, what they are. Firstly, let us see chain, है ना? Parent chain is same only, right? 2 phenyl, 1 carbon, 2 phenyl, 1 carbon. Chain is not possible, right? Okay. Functional group, COO, this is CO. If you talk about this thing here, this is COOH. This is not COOH. It is COO, and here you have 1 H. And here you have link to this one. So again, functional isomer we can't say, because functional group is not different. This is not COH. If it would have been C double bond O, OH, and here you had 2 phenyl rings, then I would say this is function. But this is not function. This is not COH. This is OCOH, right? Okay, position, so definitely position it is not, right? There is no proper function group where position is getting changed. If you talk about the metamers, there are two bridge. This is a bridge. You have two rings, phenyl and phenyl. Here you have diphenyl and here you have hydrogen. So it is going to be metamer. Okay, metamer. Chalo. Next is which of the following forms the geometrical isomer? है ना? Geometrical isomer. Geometrical. So which of the following forms geometrical isomer, guys? Geometrical isomer. So as I told you, this will form geometrical isomer. This will form geometrical isomer because same substituent on the different sides, right? Here, this is a question, right? Now, if you talk about this CH3 here, this is the double bond, right? To this double bond, you have geometrical isomer they are talking now. This is C, this is H, and this is CH3, okay? This is N, this is OH. Here you have one lone pair also. It is showing syn and anti. Syn and anti isomerism. In oxime now you have syn and anti isomerism, right? So answer is D is the correct answer. All of them are showing geometrical isomerism. Okay, all of them are showing geometrical isomerism. So answer is D is the correct answer. Next is which of the following cycloalkanes will show cis-trans isomerism? Now they are asking you cis-trans isomerism. Cis-trans. Cis-trans, so beta, basically they are asking you the geometrical isomerism only, right? But they don't want any EZ or anti-syn, right? Substituents on different carbons, so it is show. Substituent on different carbon, it will show. Substituent on same carbon, it will not show. Substituent on different carbon, it will show. So, which of the following will show? The answer will be 3. This will show, this will show, this will also show. Right? A, C and D are going to show you the, wait a minute. If you see this here, here you have CH. If you talk about the other side here, wait a minute. If you talk about the other side here, this is basically double bond. This is CH3. This is H. I'm just talking about this thing here, okay? So this is H and this is H also. Right? This is H and this is H. So this is the question for us. Because you need to have at least 2 substituent on some 2 carbons to apply that method. Here we have only 1 substituent. That means if I compress this, if I make it like this, this is double bond, this is double bond, this is CH3 here, this is H here. There will be 1 hydrogen and hydrogen also somewhere. And if I am making this as a double bond, there will be 1 hydrogen and hydrogen here. So this will not show you GI. Okay. So answer will be C and D. Okay. Answer will be C and D. Okay. Chalo. Cis-trans isomerism is shown by, again cis-trans, again GI they are asking you, right? So here GI is shown by which of the following? You have to tell me that. So first thing is GI is definitely not shown by this because CH3, same side. It shows GI because H and CH3, H and CH3. This is having hydrogen, it will not show GI. This is 1, 2, 3, 4, 5, 6 membered, it will also not show GI. So answer is A is the correct answer, okay? Right? Beta, let me just complete the questions related to structure and geometrical isomerism. After that, I'll give you the break. Right? Next is number of structure isomerism of compound having molecular formula C4H7Cl. Right? Okay, C4H7Cl. Now, so here you have to make the structural isomerism. Right? It's a lengthy questions. Okay, lengthy questions, not tricky questions. They are not. They are lengthy questions. Okay. So, first isomer is going to be your. Basically, if you see the formula here, C4H7. We know that this is basically CnH2n only. CnH2n only, it's just that replacing that, it's just that you have replaced the CnH2n, you have replaced one hydrogen with halogen. This is what you have done. So what we have drawn in CnH2n, we know that two things are possible, right? There is possibility of cycloalkane also. So firstly, we will draw cyclo, right? Cycloalkane, chlorine can be opposite, right? If you have cyclopropane, chlorine will be outside. This is the structure. If you remember, this is the structure that I drew for CnH2n, right? Same kind of question they are asking. Here I know that chlorine can have different positions. They can be on the same position, they can be on the opposite position. So chlorine can be here also, right? It is also possible that chlorine is linked to this side only. That means here you have hydrogen and here you have CH2Cl, right? So there are three other possibilities of arranging this. But is there any possibility of arranging cyclobutane? No, right? Okay, so for the isomers, we have made it from that thing only, right? 1, 2, 3, 4. Now, we know that CnH2n is also the formula for alkene. That means isomer of alkene cannot exist, right? Alkene cannot exist. Now, alkene are also existing. So, let us see. Now, guys, this is very lengthy and time consuming, right? Okay, but you need to have a proper trick on your head that CnH2n is cycloalkane or alkene, right? Cycloalkane we have drawn. Now, let's talk about alkene. If you talk about alkene here, firstly, though, we are drawing different isomers of cis and trans as well, right? So, firstly, I'll tell you, firstly, draw the isomers where you have a double bond in the terminal side. Okay, so this is the double bond in the terminal side, right? Chains can exist like this, chain can exist like this, chain can exist like this, chain can exist also like this. So these are your double bond on the terminal. When you have double bond on the terminal, right? Double bond on the terminal, this is CH2, CH3, Cl, or Cl can also be present here only, right? So that is why we have drawn this thing, that is CH2, CH2, Cl. Instead of CH2, CH3 and this Cl, we have drawn CH2, CH2, Cl. So these are the other two isomers. After that, you can also, in the terminal alkene, you can also change it like this. Now do the branching, right? Do the branching on the alkene only. Here the branching was on the side chain, right? On the side chain. This is I am talking about terminal alkene, okay? How to make different isomers. Now, after this, do the branching on alkene itself. If you do the branching here, either it can be methyl or it can be CH3. So, based on that, we have 4. If you have this alkene in the center, right? So, if you have it in the center, in the center, in the center, in the center, right? So, what are the different branches you can have, right? First is 2 methyl groups and 1 Cl here. That methyl groups on different side. Next is you are having 1 hydrogen and CH2, CH3 and 1 chlorine and 1 hydrogen, right? This is possible. Now I am even dividing the carbon and carbon on both sides. That you have CH2Cl and you have CH3 here, right? So these are totally 12 isomers that you will have, right? Achha, I'll give you one simple thing. Yeah, if they give you this kind of question, right, which is very time consuming, and you know any other question which is less time consuming, do that. Okay? In the end, why I am giving you this tip? These questions do only if you have done all the questions that you already know. Right? In the end, when you have time, do these kind of questions. Otherwise, so just remember that for C4H7X or any other substituent, the isomers are 12. Right? Okay? Understood? Chalo. Now, next we have assigned double bond configurations. So these are my favorite kind of questions which need concepts, not your drawing skills, right? They are testing your drawing skills, I think. Now, assign double bond configuration for the following. You have to assign the double bond configuration. So guys, as you can see here, you have one double bond, right? Okay. This is Cn, this is Cn, right? Wait a minute. If I want to see on the same side, this is carbon, this is carbon. This carbon is having 3N, 1, 2 and 3. This carbon is having 2H2. So definitely the one having triple bond with nitrogen is having more priority. So this is 1, this is 2. What about this one? Here this is carbon with 3 nitrogens. Here this is carbon with one more carbon with one hydrogen and with carbon. Don't look for the other big group. Just see nitrogen will have more priority as compared to hydrogen or carbon. So answer will be more priority will be to this side and then to this side. So definitely this is opposite. So answer will be E for this one. Answer will be E for this one. Okay. What about this one? What about this? But I got it now how I'm solving. Just don't see, okay ma'am, that looks like a bigger group. Ma'am, let's give it one priority. I'm telling you one by one, you have to see only the atoms, right? So here, this is the double bond. This though we have done. So I'll just erase this. This is the double bond, right? Here, this is carbon. Carbon is basically connected to 2 oxygen. That means 1 oxygen, 2 oxygen and 1 hydrogen. Here it is connected to 2 hydrogens and then 1 oxygen and then hydrogen. Okay? Understood? Now, here that means carbon and carbon are the same. This carbon is further connected to 2 oxygen and this is only connected to 1 oxygen. Definitely 2 oxygen have more priority as compared to double bond oxygen has more priority. If you want to cancel this beta, it's like this. Okay, if I want to draw this, it's like this. C double bond C. This is C, O, O and this is H. This is C, H, H and O, then you have H. Right? So that's why I'm telling you that here carbon, carbon will be cancelled because same. Then hydrogen, hydrogen will be cancelled. Then oxygen, oxygen will be cancelled. Now you are left with 1 hydrogen and 1 oxygen. Which has more priority? Oxygen. So answer will be this will have more priority as compared to this. Right? What about this side? What about this side? Here you have carbon which is further connected to, here you have carbon which is connected to 2 hydrogens and 1 carbon. 2 hydrogens and 1 carbon. Okay. This carbon is connected to 1 carbon, 2 carbon and 1 hydrogen. So I'll just write it here 2 carbon and 1 hydrogen. Okay. So here it will be carbon. Wait a minute. This carbon is connected to 2 carbon and 1 hydrogen. Okay. Here the common factor is carbon, carbon, they will be cancelled because they are same. Hydrogen same, so they will be cancelled. Again carbon is same, so it will be cancelled. You are left with 1 carbon here and 1 hydrogen. Definitely carbon has more priority. So here priority number 1 will be given here and 2 will be given here. So they are also opposite. So this is also E. So answer will be C is the correct answer. Okay. Got it guys? Only few have answered it. Yes beta. Answer is E. E is the correct answer. Are you able to understand this? Okay beta. Is that clear to everybody here? Beta, is that clear to everyone here or not? Okay, so that is the way how to solve E, E and ZZ kind of configurations. Next is they are asking you, which of the following pairs of compounds are not position isomer? Position means they have the same formula, they have the same functional group. Position is different, okay? Are not position isomer. So it's 1, 2, 3, 4 carbons, 1, 2, 3, 4 carbon. Position is different, so this is position isomer. 1, here you have alkyl, this is alkyl, this is the chain, this is the chain. Both are same, but the position, which of the following is not a position isomer, right? See, this is definitely not metamer, right? Because CH3 both are same here. This is CH2, CH, CH3, CH3. This is CH, CH3, CH3, CH3. First, let me, okay. Huh. Wait a minute. So if you make the numbering here, it will start from this side. So it will be 1, 2, 3. Here it will be 1 and 2. Right? So the numbering is different. If you number this particular chain here, that will be different. That means the position of this is going to be different. Right? So this is also the position isomer. What about this one? This I told you in when we were solving the questions, right? This is 1, 2, 3, 4. 1, 2, 3, right? So here the parent chain is different, right? So that is why this is not the position isomer. What about this one? Here it is having two positions, 1 dash 2, right? Then 1 dash dash 2. That means two carbons are in between. So this is also the position is variating. So here also this is position. So answer will be C is the correct answer, which is not a position isomer, okay? Because here the parent chain will start the numbering only, right? So answer will be C is the correct answer, okay? Next we have, which of the following pair of compounds may be regarded as both functional isomer? Both has functional isomer and position isomer, right? So which of the following will be both position and functional isomer? Okay. So firstly, the compounds that they are drawing is benzyl alcohol, right? Methoxybenzene. Okay. Benzyl alcohol is this thing, right? Methoxybenzene. They are asking the which of the following both has functional and position isomer. Methoxybenzene is this thing. When you have benzene, but here you have OCH3. Now these are functional group are different, right? So they can be regarded as functional isomer. But position, we can't say the position they are changing, right? They can only be regarded as functional isomer, right? Functional, basically, wait, right? They are only regarded as functional isomer because the function, this is a very, very good question, okay? Because this is a good question actually, right? So because both are regarded, this is OH, this is ether, so this is only regarded as functional isomer, right? Not position, position is not changing. Second is orthocresol. Orthocresol is basically when you have CH3 on the ortho position you have OH, that is called orthocresol, and paracresol. Now, paracresol and orthocresol are only the position isomer. They are only the position, only the position is changing here, right? So, this is also not the correct answer, right? This is functional isomer. This is only position isomer. Benzyl alcohol and orthocresol. If you talk about benzyl alcohol, this is the benzyl alcohol, right? And this is the orthocresol. CH3OH. Now, if you talk about the position, yes, the position is changing. Earlier OH was present here, now OH is present here. So it is regarded as position isomer. But the interesting thing about this is that here OH is connected to aliphatic. Here it is connected to aromatic. So it is connected to a different thing, right? So they are going to give you different tests. So they will be regarded as different functional isomers, right? So that is why this is also functional isomer as well as position isomer. Okay, it is both functional isomer as well as position isomer. Okay, a good question this is. So answer is C is the correct answer. Next you have which of the following pairs of compound is ring chain? This is simple. I want you guys to answer this. Okay. Very simple question. Let us see how many of you can answer this. Let us see how many of you can answer this, okay? Let us see that. Yes, everybody in the comment section, how many of you can answer this? Yes, beta? Okay. So, we know that ring chain means it should have one cyclic and one alkene. This is cyclic, but this is not alkene. This is not at all. This is not even ring and chain. This is both chain and both rings and rings. Not possible. Here you have one cyclic and one is your alkene. So answer is this one. One is cyclic, one is alkene. So answer is C is the correct answer. Okay. C is the correct answer, guys. C is the correct answer. Got it? Everybody? Everybody got it or not? Okay. The most stable enolic form of 2,4-pentane dione. 2,4-pentane dione. 2,4-pentane dione basically means 1, 2, 3, 4, 5. 2, 4, 2 and 4 pentane dione. CH3, this is H, this is CH3, right? This is CH2, right? Okay. So first thing is, at one point, both of them will not be converted into the enolic form. Okay. So this is not stable. This is not stable. Right. Okay. These both are not stable. What about this one and this one? One is double bond. What is the difference then? Acha. Now the difference is, here they have put the double bond here. Here they have put the double bond here. Now the double bond, which is like the alkene, which is more highly substituted, that is more stable. So that is why this is not going to be the correct answer. This is more highly substituted. So answer will be B is the correct answer. Okay. B is the correct answer. Right. Okay. Yes. Chal. Right. Beta, this is not stable. Okay. Both of them will not be converted. Right. Okay. That is why this is not a stable. This is stable. One of them will be converted with a more stable alkene. Okay. Now, next is, among the following, very, very important question. Okay. This is the very, very important question. As it is, this question can be asked. Okay. Which among the following compound, the one which will not show tautomerism, right? The one which will not show tautomerism. See, if you see these two things, because this is complicated now, we'll see that. Here you have, this is alpha, this is alpha, both have alpha, sp3 and hydrogen also. This will show tautomerism. This has alpha, this will also show tautomerism. This has alpha, both will show tautomerism. Right? Okay, alpha which is having sp3. Now, the condition is between A and B. This is the important factor, right? See here, this is having the alpha carbon and this is sp3 and this sp3 carbon and this also have hydrogen. Two hydrogen are present. From this side, it will show the tautomerism. But from this side, here also you will say, ma'am, this is sp3, ma'am. Ma'am, this is also having alpha hydrogen, ma'am, because one hydrogen will be here, ma'am. From this side also it will show. But that is not the correct thing. Reason being, after the conversion, what will happen? This is your OH and this will get converted to double bond. This will happen after tautomerism, enol form. Now this will become sp2 hybridized. And in these kind of compounds, right, this particular carbon, right, in your bicyclo compounds, if you have this carbon, which is the bridge head, in which you have the bridge, right, if it is sp2 hybridized, then it is not a stable condition. Got it? That is why this tautomerism will not occur only. Right? That is why this tautomerism will not occur, but in a compound, this tautomerism will occur. So that is why the overall compound will show tautomerism, right? Okay. Now, what about this thing? What about this thing? Here you have carbon, right? This is, ma'am, sp3, ma'am. Yes. But beta, this is not having no alpha hydrogen. No alpha hydrogen. So from this point, it will not show tautomerism. This point, it will not show tautomerism because sp2, after tautomerism, bridge head sp2 not stable. That is why it will not show tautomerism. Answer is B is the correct answer. Okay, got it? Very good, Shubham. Very good. Very good, Kritik. Very good. Okay, now next is which of the following pairs of structure does not represent tautomers? Now, which will not represent tautomers? Can you tell me? Which will not represent tautomers? Tautomers. Tautomers. Okay. Which of the following pairs does not represent tautomers? Okay. So here it is OH. We know that this is double bond O. This is sp2, but this is sp2 also. This is 1, 2, 3, 4, 5. Fifth is also sp2. So this will definitely not represent tautomer, right? Okay. Here also it is the same case. This is 1, 2, 3, 4, and fifth. Again, it will not show any tautomerism. Wait a minute. If you talk about this C double bond H here, right? This is OH here. This is 1, 2, 3, 4, 5. One double bond is shifted to this 2 and 3. One double bond is shifted to 2 and 3. And then this is shifting to 4 and 5. Hydrogen is shifted here. So it will be CHOH. This can show tautomerism. This can show tautomerism. This will show tautomerism. Got it now? How? As you can see here, 1, 2, it is shifted to 2 and 3. 3 and 4 is shifted to 4 and 5. This is 1, 2, 3, 4, 5. Right? First is positioned to 2 and 3. 3 and 4 is shifted to 4 and 5. Hydrogen is shifted here. Right? So it is going to show. This one does not represent. Here you have N. Right? This is to proper N here. What about this one? What about this one? If you look at this, this is CO. This is also not showing, does not represent. Huh? So this is O. Wait a minute. Enol. This is not enol. Ketone. And this is enol. If you talk about this thing, guys, just give me a second. If you want to convert this, right? If you want to convert this following does not represent, right? So if you want to convert this, this is 1, 2, 3. Here, so 3 is only sp3, right? And you have one hydrogen here that will be shifted here, and it will become double bond here, double bond here, double bond here, and this will be OH. So that is also possible, right? This is also possible. I think answer should be B. So the following does not represent tautomerism. How come this is not representing? So the following does not represent tautomerism. Let me see that in detail. If you talk about this as 1, this is OH. Okay, if I talk about this, this is 1, 2, 3. This, so it will not go, right? Yeah, B does not have internal tautomerism. Basically, they are showing. Okay, internal tautomerism. Just give me a second, guys. This is OH. 1, 2, 3. This is shifted here. this is shifted here, and hydrogen is shifted here. Okay. Then here also there should be some concept. Okay. This is not doing by direct method, it is doing by some other method. Okay. So let me just show internal transfer is happening here. Okay. Just like this. So this is COH, OH here, right? CO, this is HOH. If I talk about this as 1, 2, and this is, if I talk about this is 3. Okay, if I'm just joining these two things, just like I joined these things, 1, 2, 3. If I'm taking this as 3, 1, 2, 3. Basically, transfer, you need to transfer now. So it is transferring from 1, 2 position to 2 and 3 position, it is joining. 1, 2 to 2 and 3 position, it is making a join here, right? Then to third position, it is shifting to the first position, right? So this is making a OH here. I need to draw the structures, guys, on the next slide, right? Then only I'll be able to explain what is happening here. This is benzene, right? On benzene, this is a good question. Okay, I think this is a question of JEE advanced, not asked in your JEE mains. Okay, this is not asked in JEE mains. This is a question of JEE advanced, right? Because till JEE mains, so they ask only simple questions, not these kind of questions. Okay, but still, because we have this question here, then we will solve this. Now, basically, what we are doing here, you have this question. What will happen here? This is 1, this is 2. You will take carbon and hydrogen, carbon and oxygen or nitrogen as 1, 2 and 3. Now this is very close. That is why this hydrogen can easily shift the hydrogen to its to this side. So this is your 3, right? Okay. I am not taking alpha as this one. I am taking alpha as this one because it is very near. So what will happen? What will happen? I'll just again draw the same thing here. I'll just again draw the same thing. It will be double bond here. C double bond OH, COH. COH. Right? Now what you will see here, 1, 2 is going to shift to this 2 and 3. So that is why this is 1, wait a minute. So this is 1, this is 2 and this is 3. That is why one bond will be formed between 2 and 3, right? Because one electrons are shifting there, right? Now because double bond is shifting there, so double bond will be erased here, right? And one hydrogen from this third position will be shifted here, right? So this will form your CHOH and this is O, so this will be tautomerism, okay? So this will be your tautom. Basically, internal shifting is happening, right? Internal shifting is happening here, right? Prototropism is happening here, right? Similarly, this is the same case here. The same case here is you have, okay, here so I can explain here only, right? So this is 1, this is 2, this is 3. Double bond is shifting here. So what will happen? One new bond will be formed here. One new bond I have formed here. One hydrogen is shifted here. So here what will happen? Hydrogen will be shifted because double bond is shifted, hydrogen shifted here. So again that is the case of tautomerism. Here also, here also, here also. Here not simple tautomerism are not given here, right? And here they are considering not it as H and H. They are considering that you don't have proton here, right? You don't have proton here. So if I talk about this particular slide, here you have a negative charge, right? If you talk about a negative charge here, this is 1, 2, you have, okay. So that is the reason what will happen because, see, it's not like if it would have been this thing. It would have been this thing that you don't have a negative charge here and here you have OH, right? And here you have a simple thing like this. If it would have been this thing, phenol and this one, then this would be a tautomerism. But because they are taking it as anions, that's why they are saying that it is not under the tautomer. So this was a very good question. Exactly, this was a really, really good question. Okay. So Especially this thing, and this thing, that was really good, because uh, this way how to do the tautomerism, right? See, concept is same only, that 1, 2, 2, 3 hydrogen is shifted. Concept is same only. It's just that when you don't have a bond, how even in that case tautomerism is happening. Okay. Option B. Okay. So, for example, you have, this is your compound. Okay. So, what you have to do? 1, 2, and this is third. Now, we know that it does not have alpha hydrogen, but the concept is tautomerism is what? That is proton transfer, prototropism. So, proton will be transferred. Now, if you have CHO here and COH here, then it will not happen, because they are in the adjacent position, right? They are very close to each other. Only in that case this will happen. For example, you have a compound like which has COOH here and CHO here, then it will not happen. Okay, in that case it will not happen. Now, here what will happen? This is 2 and 3, right? That is why, because it is very near, so that's why I have drawn 3 here. Now this 1, 2 is shifted to this 2, 3 bond. That is why I have made new bond, that is 2 and 3. And this hydrogen on the third is shifted to the first. So hydrogen is shifted. So this will become CHOH, and this is O. This is the same thing that is given to you in the question here. COHOHH. Okay, so that is representing tautomerism. Right? Okay? Okay? Yes? Huh. Yeah. Yeah, this is the concept that I taught you tomorrow, na? Huh. Here the hybridization is not same. In this case, it is sp2. Reason being, now why it is sp2, that is also a very good concept. The concept in this question are really good. Yeah. The concept in this question are really, really good. Really good. Right? So now the concept here in the hybridization that is involved is, if you have carbon here, right? You have one hydrogen here, you have one negative, 1, 2 bond. If you talk about the hybridization, usually you can say that this is sp3, but that is not the correct answer, as I told you tomorrow in the yesterday's lecture, that when this carbon ion is in the resonance, when the negative charge is in the resonance, right? In that case, we will not consider that while calculating the hybridization, right? So here, that is why we will not consider that in the hybridization. So it will be 1, 2 and 3. It will be sp2 hybridized. And now that is the reason. Okay. L lone pair is busy in resonance. Yeah. Delocalized, you can just mark 3, 4 things here. Delocalized carbon ion, not in resonance, not in hybridization. It is not considered as in the hybridization. Okay, so 3, 4 concepts we have learned from here. First is this, and this. That was the important concept. Then you have delocalization of carbocation. This I taught you tomorrow also. Right? Okay, chal. Now, next is, I think that was a question of JEE Advanced. Right? So, which is not position isomer of A? Which is not position isomer of A? Now this you will feel this is as a simple question, right? Position isomer, right? That means the position has to differ. So the very simple, yeah. This is the very simple question. Now what we have done just now, this is a good question, simple question, right? Position isomer means position should change. So here you can't say any position. It's the same exact thing, right? So this is not a position isomer, right? Next is which can exhibit tautomerism, right? Again, the same concept, tautomerism. Which among these can exhibit tautomerism? Which can exhibit tautomerism? This can't exhibit. This can exhibit. This also 1, 2, 3, 4, 5 cannot exhibit. So only second will exhibit the tautomerism. Okay, right? Only 2 will exhibit the tautomerism. Next is number of optical isomer possible. Wait. I think that we will do after some time, right? Calculation we will do after some time, right? We have not done optical isomerism calculation yet. Now, this is highest enol content will be shown by highest enol. Enol content means which will have more enolic forms where like enolization can happen more. So this are to eliminated because here only two are present. Here you have three, here you have three. But this is not involved in the tautomerism. Only this can show, only this can show. Here this can show, this can show, this can show. So B is the correct answer, right? Okay. That can show tautomerism. Okay. Now, next is which of the following show geometrical isomerism? Geometrical isomerism is shown by which of the following? Right? Okay. This will not show because 2H here. This will not show because 2H here. This CH, HBr. In this case, if you move here CH2, CH2, move here CH2, CH2, move here CH, CH, Br. Environment is same. So it will also not show geometrical isomerism. What about this one? H is different, Br is different. Move here CH2, move here CH2, move here CH2, move here Br. So that means environment is different. So C will show geometrical isomerism. Okay. C will show geometrical isomerism. Okay guys. Chalo. Now these questions are simple. Number again. Number we have. Number though we are not going to do now. Number we will not do. That I will give you the formulas. From there we will solve. Number of different chain isomers for C7H16 is. Number of different chain isomers they are asking. Different chain isomer, guys. So again, lengthy question. This is very lengthy questions. You have to draw these isomers again and again. If I would advise you to do these kind of question in the end because they are very time consuming, right? Just the way we have done these other questions in just seconds, okay? But these are not the questions that you can do in seconds, okay? So number of chain isomers you have to do. That means chain should be different. 7, that too 7. C7H16. That means they are talking about CnH2n plus 2. That means we are talking about alkane here. So alkane will, how can it form different isomers it can show, right? Okay. So now, beta, this to you need to draw yourself only, right? N-pentane, N-methylhexane, N3-methylhexane, 2,2-dimethyl, branching we are increasing, 3,3-dimethyl, 2,3-dimethyl, 2,2,3-dimethyl, then more increase of branching. This is 3 branches it is having, 2,4-dimethyl, then 3-ethyl pentane, right? Okay, so different isomers that it can show, right? Okay, chalo. So next is match the following. Now match the following. Match the following, basically you have to tell which is chain, which is what. So pair of compound you have N-propanol and isopropanol you have. First is N-propanol and isopropanol, okay. Propanol and propanol. Firstly, so you can give it an idea. Propanone and propanol is functional isomer. So answer will be C is 4. C is 4 is here. This is eliminated. Now D I have to see whether it's 3 or 2, right? D is neopentane and isopentane, right? D is neopentane, isopentane. Definitely neopentane and isopentane, the chains are different, right? Neopentane is what? Right? 1, 2, 3, 4, 5. Okay, this is neopentane. Isopentane is this thing. So here you have, this is the chain, here you have, this is the chain. So neopentane, isopentane is 2, right? So this will be eliminated. A is already eliminated. So answer is either C or D. Here I have to see whether B is third or first. B means methoxypropane, ethoxyethane. Methoxy, definitely they are metamerism, right? So B is 1, right? So answer is D. N-propanol, isopropanol. N-propanol, same chain. Isopropanol, position will be different. So definitely position isomer. So answer is D is the correct answer, okay? D is the correct answer. Next is, which of the following is metamer of the given compound X? So I have a given compound, you have to tell that which of the following is the metamer of the given compound. this should remain same. NHCO. Dekho, here this is NHCO. This also, so this is NH. This is the functional group has changed, so this will not be the answer. Here you have benzene and benzene. This is not even the isomer, right? So this is cross. This is not even the isomer. This is also cross. Then you will say, ma'am, but the chain are the same only. You have just twisted. Here, benzene is attached to nitrogen. Here, cyclohexane is attached to carbon. Here to this carbon, benzene is attached. That is why they are metamers of each other. Right? So answer is A is the correct answer. Okay? A is the correct answer. Okay, guys. Next is, which of the following represent correct matching? Okay. Which will represent the correct matching? Okay. OH and this is HCHO. This is basically wait a minute, OCOH, right? So here definitely you have interchanged the this is, don't confuse it by functional, huh? This is a functional, the functional group is same only. You have just interchanged the chain CH3H, CH3H. So that is metamer only. That is correct. Which of the following is the correct matching? So this is the correct matching. Here you have position isomer. Position is changing. Definitely yes. Okay, two of them are correct. Is this okay? Here you have CH3, CH, CH3. Again, this is the incorrect matching. This is not tautomerism. Right? What about this one? CH3, CH2OH. And this is OCH3. Basically, this is functional isomerism. They are asking you which of the following represent correct. So A, B and D will represent correct. A, B and D will represent the correct matching. Okay? Okay? Guys, everybody. Beta, what happened? Where is the energy? Ma'am, we are tired, ma'am. Tired as hell, ma'am. Acha. Next is tautomerism is exhibited by. Tautomerism is exhibited by which of the following? Tautomerism is exhibited by which of the following? Okay, so this can exhibit tautomerism because it has alpha, so it will exhibit, and hydrogen is also present. This has sp2, sp2, and then sp2, sp2, again sp2, so it will not represent. Even on the fifth position, it will not represent. This is having this alpha, and this is having this alpha. This is having both the alpha, so it will also represent, right? This is many answers questions, okay? So this is basically CH double bond O. I think this is a repeated question, isn't it? This is also exhibit. So A, C and D will exhibit. A, C and D will exhibit the tautomerism. Okay? A, C and D will represent the tautomerism. Right? Here it will be connected to ketone form, alpha and alpha. That is why they will represent the tautomerism. Next is, which of the following will have trans isomer? Trans isomer, guys. Trans. I know we already completed that. Which of the following will have trans isomer? Trans. This is not even GI. This is cis, right? And wait a minute. This is also cis. Which of the following will have a trans isomer? Right? Okay. The following will have trans isomer. To talk about this here, CH2, H is also not representing. Out of this, so I can say one can have, if you look at this thing, right, hydrogen and hydrogen, if forcefully you have to make, then you can say first, forcefully you have to make. Otherwise, so first is also not your geometrical isomer, okay? है ना? Will have the trans, अच्छा, will have the trans isomer. I think which of the following is a trans isomer? Which of the following will have the trans isomer. Means this is your cis, right? This is also cis. When you just convert this here, this is H, this is H, this is CH3, this is CH3. Basically, they are asking you which of the following is geometrical isomer. Okay? Basically, they are asking you which of the following is GI, not trans. Okay? So, this is not a GI, right? This is cis. It will have opposite trans. This will have, depending upon the configuration, cis and trans, both it will have. It is cis, so it can also show trans isomer. So answer is B, C and D. Right? Okay. Statement just. Not trans. They're asking isomers. Yes. So they're asking the isomers here. Okay, guys, that's it. Wait a minute. Now, we have completed a lot of questions now. Na? So after this, guys, after the break, what we are going to do here, we are going to start with the optical isomerism, right? We're going to, just very little part is left, okay? We are going to do optical isomerism. Optical isomerism. After that, we will do, after optical, wait a minute, optical isomerism. Then we will do little bit, we will understand about DLRS. Hai na? You should know that what does they mean if they ask you that. Then we will talk about conformers and the questions based on it. Right? Okay? Yes? Ma'am, please send the PDF also. Yes, I'll send the PDF. Don't worry. I'm not going anywhere. Right? I'm just giving you the break. Okay? So I'm giving you break for 15 minutes. Let me have the calculations also we will do. Let me write it here. The calculations also, conformers, and the calculations. And the calculations we are going to do. Right? And the calculations we are going to do. Okay? Yes? Chalo. Chalo. Okay then guys, I'll see you all after the break. Now let's have dinner also, hai na? Because otherwise we will not have energy. I'll see you all at which thing you want me to repeat. This is, I'll see you at 9:20, okay? 9:20 p.m. I'll see you all. 9:20 p.m. Okay? Chalo. I'll see you all at 9:20 p.m. Hello, hello. Okay, so yes, everybody, am I visible? Everybody in the comment section. Everyone in the comment section, am I visible? Am I audible to all of you or not? Sure. Okay, so let's restart the session. Right, I hope you had your dinner. Right, because without dinner, though, we can't have the energy to do something, right? So, yes. Now, let us start and continue the session. Okay. Firstly, let's go through the concepts here. See, I have given you the formulas, right? If you say that, ma'am, do I need to cram this formula? Yes, beta, you need to cram this formula, right? Okay. So, asymmetrical means which do not have any plane of symmetry, right? Okay. So, the one which is not having any plane of symmetry, you are going to use 2 raised to power n. Now, ma'am, what is this n? This n is going to be number of geometrical centers, number of double bonds showing GI. Only those double bonds that are going to show GI will be included in this. Only those double bonds, okay? So I'll also give you the examples. For example, if that compound is asymmetrical, that means it has no plane of symmetry, no symmetry it is having, then this will be 2 raised to power n. Okay. If it is symmetrical molecule, that will be 2 raised to power n minus 1 and 2 raised to power p minus 1, where p is equals to n by 2. If n is even, p is equals to n plus 1 by 2 if n is odd. Okay. Now, we will see this question here. Now, guys, what you can see here is, just give me a second here. Just after dinner effects. Okay. So, this is a double bond and here you have one hydrogen and one hydrogen here. Right. So, that means this is not a center of geometrical isomerism. But this is a center of geometrical isomerism. Here you have one hydrogen and one this group. Here you have one hydrogen and one this group. That means this is not a center of geometrical isomerism. This is a center of geometrical isomerism. So, n is equals to 1, which is a odd number. First, you need to tell me, is this symmetrical or asymmetrical? As you can see, this compound, this does not have any plane of symmetry, right? You can see that it does not have any plane of symmetry. It is asymmetrical in nature. That is why we can say that we will use the formula of geometrical isomerism as 2 raised to power n, where n is equals to 1. So, answer will be 2 is the correct answer, okay? 2 is the correct answer. Got it? This is how you're going to solve geometrical isomerism. Next question is, okay, I'm going to give you one more question regarding this, okay? Chalo, I'll give you the next page. Chalo, let's do this here only. For example, you have a compound like this, okay? Br and this is Cl, right? Chalo, let's do this. So we will do that in the question only, okay? We'll do that in the question only when we will solve stereoisomers, and that way I will tell you that what are the different I was just looking for one symmetrical center here. So symmetrical, chalo, let's do one thing, C double bond, C double C, right? And this is, let's do this, this is CH3, right? This is CH2, CH3. Again, this is CH3. This is CH2, CH3. Right? And this is hydrogen, CH, and this is also hydrogen. Now, guys, as you can see, this double bond is also having 2 different groups on same side. This is also having 2 different, one is this group, one is this group. That means 2 different groups. That means this is the center of geometrical isomerism. This one, here it is showing one, this is also different, this whole is also different, this is also different, this is also different. So, this is also showing geometrical isomerism. That means it is n is equals to 2. But it has a plane of symmetry which will cut this into equal halves. So this is a symmetrical structure. So in a symmetrical structure, you will have the formula that is 2 raised to power n minus 1 plus 2 raised to power p minus 1. Now, here as you can see, your n is even. N is even means p will be n by 2. So just answer this. P is equals to n by 2, that will be 1. For symmetrical, it is 2 raised to power n minus 1 plus 2 raised to power p minus 1. It will be 2 raised to power 1 plus 2 raised to power p minus p is equals to 0, that is 1 only. So 2 plus 1 is equals to 3. 2 plus 1 is equals to 3. So number of geometrical isomerism is going to be 3 here. Okay. Sank, can you please focus here? Hana? Can you please focus, beta? You can comment down anything right after the live. I'll see, but right now just focus on this thing, right? It is going to be 3. 2 raised to power n minus 1, 2 raised to power p minus 1. This is the formula you're going to apply. N is equals to even, so p will be n by 2. Just apply this formula. You will get your geometrical isomers. Okay, guys? Got it? You need to paste these formulas somewhere, right? Okay? Chalo. Now, that is your number of geometrical isomerism. These kind of questions they ask you, right? Calculate the number of geometrical isomerism. Next is optical isomers. Okay. So now basically for optical isomer, firstly we need to see what exactly is this optical isomerism. If I tell you in brief that basically optical isomerism is when you have a plane polarized light. This is not a plane polarized light, right? If you pass this through Nicol prism, you will have a plane polarized light. Okay, that is only in one direction. If you pass this through a compound, right, 3 things will happen. Either it will rotate towards right, or it will rotate towards left, or there will be no rotation. Now, if it is rotating towards right, then we will say it is small d, or we also call it as positive, that is dextro. If it is rotating towards left, we say this is levo, that is minus. If this is not rotating, then we say it is optically inactive. That means the compound that show rotation of this plane polarized light are called optically active compounds. Now, ma'am, this though we will not do every time. Na? This is experimental thing. So, how to do it with the help of just by seeing that molecule, right? For that, what we have, for that beta, what we have, for that we have this thing, right? Okay. For that we have this thing, that is optically active and optically inactive. Optically active means you are asymmetrical. For optically active, just remember AC. For optically active, they need to be asymmetrical. That means there should not be any plane of symmetry, any center of symmetry. And that molecule, that compound should have at least one chiral carbon. Only then it will be optically active. Just remember AC. Optically active, asymmetrical, chiral. And the opposite thing is optically inactive. That means if you have any plane of symmetry, that is optically inactive, or you have not even one chiral carbon, right? The molecule will be achiral. Achiral means optically inactive. Okay. Now, what is plane of symmetry, beta? What is plane of symmetry? Plane of symmetry, I'll just explain you here, right? Now, wait a minute. Just explain you here what is plane of symmetry. Plane of symmetry basically means that if you pass a plane from here, that will cut it into equal half. If you pass a plane from here, we know that here this chlorine and this chlorine will be cut into equal halves. If you pass a plane here, that will also cut it into equal halves. Now students usually get confused, ma'am, how they are going to cut it into equal halves. Okay, that's the thing that I want to explain you. Right, guys? So for that, just remember one thing. Any molecule you remember, any molecule I'm just picking, if you pass a plane, when I am saying that you have one molecule, That means I am saying that on this carbon, you have these two things, okay? On this carbon, you have these two molecules. One is chlorine, other is hydrogen. Now, I am not saying you have to divide it like this and they will be cut into equal half. I am saying if you divide it like this, if you pass a plane like this, they will be cut into, and each shortcut only I'll tell, but this I can't tell in shortcut now, right? So here, if you pass a plane from this side, they will be cut into equal halves. Got it? So now, here you can say that why I am saying that there is plane of symmetry present. Here also plane of symmetry present. Here also plane of, there are so many plane of symmetry is present. Here also plane of symmetry is present. Okay. So here we can say that plane of symmetry is present here. Now, three specific molecules we will talk about. One is alenes, then you have spiro compounds, then you have bicyclo compounds, or you can say biphenyl. Okay, not bicyclo, biphenyls. Three molecules, alenes, spiro, and biphenyl compounds. Okay, same concept we will apply. The concept is that alenes are basically the double bonds next to each other, so they are perpendicular to each other, right? It's not like this, it's like this. Now, I will give you just simple trick on this, okay? The trick is this, okay? Based on trick only, we will do the questions. Now, two cases can happen, right? I'll just make one new box here because that was in Hindi, right? So, see, if your number of double bonds are even, or it can be odd. If your number of double bonds are odd, then it is definitely inactive. You don't even have to think about it, right? But if your number of double bonds are even, then you have to think about two things. If on same you have different, on same, or you can say same substituent on same carbon, then it will be optically inactive. If you have different substituent on same atom, on same carbon, then only it is called optically active. Okay, then only we will say it is optically active. Okay, this is a simple chart that you have to remember. Okay, now if you see this was in Hindi, right? So let's see this thing here. Now, how many double bonds you have? Double bonds are even. Okay, double bonds are even. So now we will see on the last carbon whether different substituents are attached. That means it is optically active. That means if you have even, then on the different okay? No beta, this is English channel, hai na? So in English channel, we will only talk in English, right? Okay, what about these things? What about these two concepts here? 1, 2, 3, 4. Again, you have 4, which is an even number. Here, but the problem is on one carbon, you have two same substituents. That is why it is going to be optically inactive. What about this one? 1, 2, 3. That is odd. Here you have odd number. That is why again it will be optically inactive. Got it? When you will need to take it optically active and optically inactive. Yes, everybody understood this trick here. If it is odd, then inactive. It is even, but same substituent on same carbon, then also it is inactive. Only chance it is active is when it is even and different substituent on the end carbons, right? Next you have spiro. Spiro is having the same trick, okay? Same trick will be applied here. The trick is how many rings you have? 2 rings, that is even rings. That means you will see whether on the last 2 carbons you have same or different. You have different, right? Okay, this is also different. These are also different to each other. So that is why it is optically active. That is why it is optically active compound, okay? Next. Again, spiro compounds. This is 1, 2, 3. 3 rings you have. That is, you can say n is equals to odd. That is why it will be optically inactive. inactive. It will be optically inactive. Okay. Next is, chalo. Biphenyl is also same, but here you don't have to think about even and odd because it is biphenyl. Always you will have two phenyls. So about two phenyls, usually they are in one plane only, but if very at ortho positions, very heavy substituents are attached here, then they will have the perpendicular, they will be perpendicular to each other, right? Same thing is applied here, that if at this particular position, at this ortho position, right, you have same substituent on same side. On same side you have different, on same side you have different. That is why it is optically active. Okay, it is optically active. Right? What about this one? This is CH3. This Me is also CH3 only, na? So this is also same. So it is on same side you have, here we are not talking about same carbon, we are talking same side. On same side you have same substituent at ortho position. So we'll say it is optically inactive. Guys, I can't see your energies in the comment sections. Right? Okay? Yes? Chalo. Next. Chiral center. What is a chiral center? Chiral center is which should be sp3 hybridized and it should have 4 different groups. That is the nature of a chiral center. If you draw the chiral centers here, everybody, let's draw the chiral centers here. Okay, let's draw the chiral centers here. Chalo. Let's draw the chiral centers here. This is having 2 hydrogens. This is having 2 hydrogens. This is having 1 chlorine, 1 this ethyl group, 1 this group. Right? So that is why this carbon here, this carbon that I'm telling you here, this is basically your chiral. Beta, if you don't know how to calculate chiral centers, then you will not be able to do optical, you will not be able to calculate the optical isomers. Okay, this is in your previous year questions only. That's why I'm teaching you this. If you don't know how to calculate optical isomers, how to calculate chiral centers, then it's not possible for you to calculate the optical isomer. What you will do with cramming the formula. Okay? You need to know na, about how to put the values. For that, you need to know how to calculate chiral center. Okay? This is sp3 hybridized. All the groups are different. What about this? This is not because these are sp2. This is chiral because this is 1 bromine, 1 over here, 1 over here and 1 hydrogen. Right? So that is why this is also chiral. What about this one? This is not chiral, this is not chiral, this is also not chiral because it has 2 hydrogens, that is the 2 same groups. Right? Okay? Now, let us see this thing here. Let us see this thing here. Here it should be sulfur, okay? Otherwise, so this will also be not different. Chalo. Now, if you're talking about this compound, firstly, don't just see the double bond and say it is not chiral, okay? This is 1 sigma, 2 sigma, 3 sigma, 4 sigma. That means sp3 hybridized, right? Now, it is having this oxygen are same. That is why it is not chiral. Not chiral. What about this one? Sigma, 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 sigma. That means it is sp3. Now, this is different. That means it is chiral, right? So, here it will be your chiral center. This sulfur is going to be chiral in nature, okay? This sulfur is going to be chiral in nature. Got it? Okay. Got it? Rishabh, don't spam beta. Chalo. Now, what about this one? This is important for you to understand. Reason? If you talk about this thing, this is a lone pair. 1, 2, 3, 4. It is definitely sp3 hybridized. 4 are different. This is ethyl, this is methyl, this is hydrogen, this is lone pair. That is why it is definitely a chiral center. Right? This is definitely a chiral center. But if you talk about this nitrogen here, you will say, ma'am, here also it is 1, 2, 3 and 4. Ma'am, here also it should be chiral. That's why I picked up this question here. Right? Now, if you see this carefully, then this lone pair is involved in the delocalization. Right? The lone pair that is involved in the delocalization is not calculated, that we have done today only, right? It is not calculated, right? So that's why it is 1, 2, 3. This is sp2 hybridized. That is why it is a chiral molecule, right? That is why it is a chiral molecule. Okay, chalo. Now, what are meso compounds? What are meso compounds? Which has two chiral centers and one plane of symmetry, that is also optically inactive in nature. Okay, meso compounds are optically inactive. They have two chiral center and one plane of symmetry. The example is, for example, this, we know that it has a plane of symmetry. It has, this is chiral center, this is also chiral carbon, two chiral carbon, one plane of symmetry is present here, plane of symmetry is present here. So we can say that this is a meso compound. This is a meso compound. Okay, this is a meso compound. Okay, what if it is a chiral? Then see, either to they will give you direct, wait for some time. Okay, I'll tell you what you have to do with chiral and achiral. Okay, now we'll just do, instead of doing R and S configuration, we'll firstly see how to calculate the optical isomers. Okay, so firstly see that. Firstly, so let us see what is epimer, right? Okay, firstly let us see what is epimer. What is epimer? Epimer is a molecule that has more than one chiral atom in it. Only one chiral carbon is different. Okay, that means if you talk about this structure here, right? If you talk about this structure here, we know that this particular chiral center, this particular chiral carbon is having the opposite configuration. Here chlorine is present on right side, here chlorine is present on left side. That means they both are epimers of each other, right? That means more than one chiral atom, but only one chiral atom, carbon is different here. Now cyclic epimers are called the anomers. This we have also done in biomolecules, right? So here we know that this is different at which position? This position it is different at, right? So all of it has more than one chiral carbon, but only at one position it is different. So that is called epimer. The cyclic epimers are called anomers, right? Next important thing is thereo and erythro. Now, what is thereo and what is erythro? The definition you need to remember, because they can also be asked. Erythro means on the same side. Okay. So when these two chlorine atoms, the same kind of atom is on the same side, that is called erythro. Erythro. When the same atom is on the opposite side, okay, this is on the opposite side, this is called thereo. This I have told you in hydrocarbons as well, right? Okay. Okay, chalo. Beta, I have done that in biomolecules. Okay, chalo. This is what I wanted to teach you. That is how to calculate geometrical isomers we have seen. Now let us see how to calculate number of optical isomers. Now, let me tell you one thing. Usually they will ask you unsymmetrical only, right? But what if they ask you symmetrical? For that, I have just put down the formulas here. Now, if they ask you the unsymmetrical carbon, unsymmetrical molecule, optically active isomer will be 2 raised to power n. There will be no meso isomer if it is unsymmetrical. There will be no meso isomer because there is no plane of symmetry. For meso, you need to have plane of symmetry, so there will be no meso isomer. Next is optical isomer is equals to optically active plus meso. And racemic mixture or enantiomer is equals to optically active divided by 2. Okay, optically active divided. That means all you need to calculate is optical isomer and meso. Okay, all you need to calculate is optically active plus meso. Okay, got it? Now, if you have symmetrical but it is having even number, symmetrical but it is having odd number, very rarely they will give you some optical isomer. If they want to make paper really difficult for you, then they will give you symmetrical or symmetrical compounds. Otherwise, so mostly unsymmetrical compounds only they will give you. But just go through the formula. 2 raised to power n minus 1. This is 2 raised to power n by 2 minus 1. This is 2 raised power n minus 1 minus 2 raised power n minus 1. Just pick this thing here. This will be your meso. 2 raised power n minus 1 by 2. Okay, that is the formula. Now, let me tell you how to solve it. Okay. So, can you see this thing here? If you have asymmetrical, beta, understand this very carefully. If you have asymmetrical, then in that case, what you will do? This is chiral, this is chiral. The question was this only, na ma'am, what is n here? The question was, ma'am, what is n here? In optical isomer, n is equals to number of chiral centers or carbons, you can say. Number of chiral carbons. Okay. So here number of chiral carbon is 2. So it will be 2 raised to power 2 is optically active, that is 4. Meso is 0 for unsymmetrical. Optical isomer are 4 plus 0 is 4. Enantiomer are optically active divided by 2. That is 4 by 2 is 2. Got it? Bacha, got it or not? Hey Bhagwan. Nobody wants that we should, ma'am, at least go through these things. Na? When I'll teach you previous year question, then you will get, ma'am, what is this, ma'am? Okay. Now, this is your symmetrical. Very rarely they will ask you, but if you talk about this is your symmetrical, because it has this plane of symmetry. It has this plane that is passing by it, right? So, when you have a plane of symmetry, in that case, it is called symmetrical. Now, n is equals to 2 because 2 chiral centers you have. Just apply the formula. I've just applied the formulas here and you will get your answer. Okay. Optically active, meso optically, total optically optical isomers and racemic mixture. Okay. Okay, guys. Got it? Chalo. Now, next is pseudochiral. Now, ma'am, what is pseudochiral? Pseudochiral also they can ask you. Beta, I am not calculating stereoisomers. Okay? Kritik, I am not calculating stereoisomers. I am calculating optical isomers. Okay? When we will calculate stereoisomers, we will put number of stereo plus a number of chiral plus number of apna geometrical isomer, both. Right? But here I am talking about optical. Optical is related to chiral carbons. Okay? So, here, as you can see, in this case, what we have, in this case, this is the pseudochiral that we have. What do you mean by pseudochiral? Here, too, we can say, ma'am, this is chiral, this is definitely chiral, but ma'am, what about pseudochiral? Right? So, pseudochiral is also included in the chirality. But pseudochiral, how you will predict? You will say, ma'am, here you have one hydrogen, one OH, but ma'am, this group and this group is same, ma'am. How can you say this is chiral? I am not saying this is 100% chiral. I am saying this is pseudochiral. What do you mean by pseudochiral? Pseudochiral means we know that this CH3, CHO, OH can have 2-3 configuration. OH can be present here, H can be present here. H can be present here, OH can be present here. Right? So, we don't know exactly the configuration, exactly where OH is, where H is. That is why it can exist as any of the configuration. We have a thing called R and S, right? That I will teach you little bit about R and S, right? So, R and S, either this can be R or this can be R. Now, depending upon whether this is R or this is S, right? It will depend on that thing. If this is R and this is R, then this will not be chiral. If this is S, then this will not be chiral. But if this is R, this is S, then this will be chiral. This is S, this is R, then this will be chiral. So basically, we don't know whether this will be chiral or not. That's why it is called pseudo-chiral. That is why they will ask you, they will only ask you this kind of concept, then you should think about pseudo-chiral. Otherwise, you don't have to worry about pseudochiral. Okay, so pseudochiral is also included. So again, I have just applied the formula here for symmetrical. Symmetrical it is. I know there is plane of symmetry that is passing through it. So here I have just applied the formula where n is equals to odd and you will get your answer. Okay, chalo. Now, next is pseudo-chiral. This I have explained about pseudo-chiral, right? Pseudo-chiral can also be present like this. If you talk about this thing, right? Now, this is chiral or not, that we have to think, right? Because if you see this directly, you will say, ma'am, this is not chiral, right? But this can be cis or trans. This also can be cis or trans. If both are cis, both are trans, then this is not chiral. But if one of them is cis, one is trans, then this is chiral. That is why this is also called pseudo-chiral. And here also we will say that n is equals to 1. Okay, here we will say that n is equals to 1. We'll put n is equal to 1, but this is a symmetrical molecule. So we'll put all the formulas of symmetrical where n is equals to odd. That means these same formulas will be applied. Right? Okay, got it? Beta, I am losing all my interest in teaching you now, because I can't see anything in the comment section. Okay, so pehle to you have such high energy. After some time, to your energy is totally low. The teacher itself will feel like, why even I am teaching? Beta, why so, like, energy is totally like such good things I am telling you, totally not even like directly these things are going to give you the marks. Okay, stereoisomer. Next is stereoisomer. Again, if you have asymmetrical, see, mostly they will give you asymmetrical only. If they give you asymmetrical, the answer is 2 raised to power n. But what if they give you symmetrical? Then the answer is 2 raised to power n minus 1, 2 raised to power p. If n is even, then p is equals to n minus 2 by n minus 2 minus 1. Sorry, n by 2 minus 1. If n is equals to odd, p will be n minus 1 by 2. Right? Now, here, what is n? Here, n is geometrical side, that is how many double bond that are showing geometrical isomerism, plus the chiral center. Right? I'll give you one example here. This is the example. Now, here you can see there is no plane of symmetry that is present. Right? That means it can be optically active. Right? Now, here we can say that 1, 2, 3 chiral centers we have. And because this is asymmetrical, so there is no double bond here. So that will be 2 raised to power n, 2 raised to power 3, and 8 is the correct answer. If you talk about this kind of molecule, right, here I am going to tell you two things here. One student was asking about stereo center. Stereo center is a different thing, beta. Stereo center is different. N value for stereoisomer is different. N value for optical isomer is different. N value for geometrical isomer is different. Okay? Okay? Here also N is not stereo center, right? I'll tell you what is stereo center also. If you look at this particular structure, this is when we are calculating the number n for stereoisomers. In that case, double bond is taken as 1. Okay, so this is my 1 and this is 2. This is chiral center. This is one geometrical center. One geometrical center that I have, right? So this will be total 1 plus 1 is 2. So n is going to be 2. After that, we know that it is even. It is asymmetrical. So wait a minute. This is asymmetrical. No. So directly you can put the value. This is asymmetrical. This is symmetrical, guys. Because if you pass the plane like this, right, you have CL here and BR here. If you pass the plane like this, it will break it into equal half. It will divide it into equal half. So here you have plane of symmetry, right? So it is symmetrical, right? It is symmetrical. That is why for symmetrical, for even, we have applied this formula, right? For symmetrical, for even, n by 2 minus 1. So P is equals to n by 2 minus 1, P is equals to 0. Just apply this formula, you will get the stereo isomers. Okay? Yes? Now, what is stereo center? That is a different thing. In stereo center, This is also my stereo center. This is also my stereo center. That means everything will be same. It's just that the geometrical centers will be doubled, right? In calculating, putting the value here, I am taking this as 1, but while calculating stereo center, this will be 2. Okay? Right? Okay? Right? Okay, beta? Got it? Chalo. Now, here, this is stereo center, that is 2 into geometrical isomer plus chiral, so it will be geometrical isomer is 1 here. Hana? Geometrical, basically we are talking about geometrical isomer is 1, 2 into GI plus the chiral, that is going to be 3. Okay? Got it? Chal. Now, next is, what if you have something like this? 1 chiral here, 1 chiral here, right? What about this one? 1 chiral here, 1 chiral here. This is your geometrical isomer. 2 plus 3. 3 is going to be your number of stereoisomers, n for number of stereoisomers, right? So n is equals to 3 here. To write n is equals to 3 here. Okay, n is equals to 3 here, right? So just put the formula, you will get your answer. But here, one more thing to remember, that what is stereo center? Stereo center is 1, 2, 3, 4. So stereo center will be 4 here, right? Okay, chalo. Okay, that's it. That was the other example of stereo center. Now let us do the questions here. First question is this one, where you have number of optical isomer possible for 2-chlorobutane. Okay, this is your previous year questions. 1, 2, 3, 4, 5. 1, 2, 3, 4. 2 chloro. On second you have Cl, CH3, this is H, this is CH2, this is CH3. They are asking you the optical isomer, guys. For optical isomer, we just see the chiral center, okay? For optical isomer, we will just do the chiral centers, okay? So this is the chiral center. This is the chiral center, right? So here n is equals to what? N is equals to 1. This is asymmetrical. So formula will be 2 raised to power n. So it will be 2 raised to power 1. Answer is 2 is the correct answer. Okay? So, beta, I have not, firstly let us do questions based on number of optical isomer. After that we will do R and S, D and N. Right? Okay? Chalo. So answer is 2 is the correct answer. Next is, let us do other questions as well. Wait a minute, let me find them. There was one more question related to GI, no? Where is that? Where is that? This is the question. Okay. Number of, this is the question that they have given you. Number of GI, geometrical isomer, possible for given structure. For given structure, number of GI you have to calculate. Okay. So, you need to see which is showing the geometrical isomer. Here H is different, D is different. This is CH3 and this whole group is different. So this is showing GI. Here D is different, H is different. This is CH3 and this whole group is different. So this is also showing GI. What about this one? H is different, CH3 is different. But this is CH2, this is also CH2. This is double bond, this is also double bond. To this one methyl is attached, one methyl is attached. To this one double bond, one double bond. One hydrogen, one D, one D. That means these two are to showing GI. But this is not showing GI because here, this group here, wait a minute, this group here and this group here, they both are same, right? That is why this is not going to show the GI. So, number of GI sites is equals to 2. right? This is asymmetrical. We can see that definitely it is asymmetrical. There is no as such POS that is passing by it, right? So this is 2 raised to power n. Answer will be 2 raised to power 2. So answer is 4 is the correct answer, okay? 4 is the correct answer, right? Okay, beta? Okay. Now, let us do some other questions, okay? Based on this, chalo. Number of optical isomers in the following compound is right. Number of optical isomers in the following. As you can see, this is your optical means you have to see the chiral center. This is chiral. This is also chiral. What else is chiral? If you talk about this carbon here, this is having one hydrogen, one this different group, this is also different group, this is also different. So this is also chiral, okay? If you talk about this particular carbon, this is also chiral because it has one hydrogen. This whole group is different, this whole group is different, this whole group is different. So this is also chiral, okay? 1, 2, 3, 4. If you talk about this particular carbon is also chiral. How? Because this will have one hydrogen here. This whole group is different. This whole group is different. This whole group is different. So that is why it is going to have how many chiral? It is going to have 5 chiral. Okay? 5 chiral. So answer is going to be n is equals to 5. Number of optical isomer. As you can see, there is no plane of symmetry. This is asymmetrical. So optical isomer is going to be 2 raised to power n. That is going to be 2 raised to power 5. That is going to be 32. Okay. So answer is going to be, okay, chalo. Now answer is going to be 32. Okay. Next is number of optically active compound they are asking. Right? Optically active compound. Now guys, I told you optically active compound. What is an optically active compound? AC. A for active, A for asymmetrical, C means chiral. Right? These two conditions should be fulfilled. Here you have plane of symmetry. This is the plane of symmetry, so this will not be optically active. This will be inactive because it has symmetry. Molecule should be asymmetrical, right? Okay. What about this one? Again, it has plane of symmetry. Again, this is not optically active. This is not having plane of symmetry, this particular molecule, but does not have any carbon which is chiral. We also need chiral carbon there. So this is also not possible. This is the chiral carbon that we have. This is HC, ethyl, methyl and chlorine. And it does not have POS. So this is basically, this is showing optically active. This is optically active, right? This is again like OH only. Here you have like there is no chiral carbon that you have. So this will also not be optically active. This particular thing, this C, this is H, this is CH3, this is CH3. It also does not have any chiral carbon, so this also will not be optically active because this carbon, this has 2 methyl group, this has 2 hydrogen, 2 hydrogen. So no carbon is optically, no carbon is chiral. So only this molecule is optically active, right? Okay, only one is optically active. Chalo. Next is number of stereoisomers they are asking. Beta, stereoisomers. Stereoisomers, everybody. Stereoisomers. Very good, only one. Stereoisomer is, this is the double bond. This is the double bond. Okay. If you talk about this, here you have methyl, here you have bromine. If you talk about this, here you have hydrogen, here you have a different group. So this is the center of geometrical isomerism. This one, this is bromine, methyl, hydrogen, and this is a different group. This is also a center of geometrical isomerism. But this, can you see any carbon which is chiral? This carbon is chiral in nature. Can you tell me why? Because one bromine, one hydrogen will be there. This group is different. This group is different. Right? So definitely it has one chiral center also. So N is equals to 2 geometrical plus 1 chiral 3. For a symmetrical molecule, the number of stereoisomer will be 2 raised to power n. That is going to be 2 raised to power n, guys. 2 raised to power n, right? 2 raised to power 3. 2 raised to power 3, that is 8. So answer is going to be D. Okay? Stereo center. Stereo center will be 2 into geometrical isomer. Geometrical isomer are 2 plus 1. Stereo center will be 5. Okay? Stereo center will be 5. Okay, guys? Chalo. Next is, which of the following are correctly matched? Now they are asking you which of the following are correctly matched. Number of GI they want us to calculate. Right? Okay. Here you have, this is also geometrical isomerism site. This is also geometrical isomerism site. So it should be 2 raised to power n, which is 2 raised to power 2, because geometrical isomerism site is 2. If you talk about this thing here, see here, so it will not be 10, it will be 0. This is wrong. Okay? Wait a minute. This will be drawn as CH3, CH double bond CH. 4 times it is. If you talk about double bond, double bond, double bond, CH3. नहीं. CH3, CH. Wait a minute, how this molecule, they are drawing this molecule? CH, wait a minute. This will be wait a minute, guys. Wait a minute. Hari, what is wrong with you? Guys, please don't spam. CH, CH, double bond, CH. Alternate it is. They are connecting it to. Acha, haan. So sorry. Let me just draw it on the next page. Okay. So CH3CH. 4. This is the only thing that they are drawing here. Okay. CH3CH double bond CH. Again you have CH double bond CH. Again you have CH double bond CH. Again you have CH double bond CH. Again you have CH3. Okay. So this is the thing that they have drawn. Here you will see that this double bond, this is the geometrical isomerism site. Okay, this is H and this is a different thing. This is H and this is a different thing. H a different thing, H a different thing, right? Okay, so this is also geometrical isomerism site. If it 4, 1, 2, 3, 4, right? This is H and this is different. This is H, this is different. So this H and a different side, H and a different side. This is also geometrical isomerism. H different, H different. 4 it will have 2 raised to power 4. So this will also not be correct. CH3, if you have 5, in that case also it will be 2 raised to power 5. 2 raised to power 5 is what? 32. That is also not correct. So answer only 1 is correct. CH3 CH. Chalo, let's draw this. Because symmetrical asymmetrical is also the thing, na? CH3 CH double bond CH1 2 3 4 5 and this is the last one. Now if I have to see whether it's symmetrical or asymmetrical, so this will be 1 2 3 then 4 then 5. This will be symmetrical, na? This will be symmetrical. This will be symmetrical, right? This will be symmetrical. This will be asymmetrical, right? This will be asymmetrical. 1 2 3 4 5 6. 1 2 3 4 5 6. If we talk about this one, let me to beta firstly see whether it's symmetrical or asymmetrical. 1 2 3 4 5 6. 1 2 3 4. Okay. 1 2 3 4 5. 1 2 3 1 2 3 4 5. 1 2 3 4 5. Okay. What about this one? 3 4 5 6. 1 2 3. Chalo. Both are symmetrical only. Okay. Both are symmetrical only. So the formula applied will be something else, right? So here n will be 5. N will be 5 and the formula applied in calculating optical isomers, right? Geometrical isomers was, if n is equals to odd, so p will be n minus 1 by 2, that is 5 minus 1 by 2. So it will be 4 by 2 is 2. So P will be 2. And the geometrical isomer will be 2 raised to power n minus 1 plus 2 raised to power P minus 1. 2 raised to power, this is n is 2, n is 4, 4 minus 1 plus 2 raised to power P is what? 2, 2 minus 1. 2 raised to power 3 plus 2 raised to power 1. So it will be 2 raised to power 3 is 8 plus this is 2. My geometrical isomers are coming out to be this only. Wait a minute. This is coming out to be 10. Why it is coming out to be 10? Let us see. Geometrical isomers, right? Geometrical isomers. Wait a second. Achha, n plus 1 by 2. N plus 1 by 2. Wait a minute. Formula I have applied wrong. That's why formula cramming is important, yaar. 3 formula. Weird formulas you have. Right? But yeah, they are important. Wait a minute. Okay. This is the question, right? Okay. Wait a minute. This is n plus 1. So things will change here, right? This is n plus 1 by 2. Till here the formula is right. This formula is n plus 1 by 2. Not n minus 1 by 2. This is n plus 1 by 2. 5 plus 1 by 2, that is 3. Right? So it will be 2 raised to power 5 minus 1 plus 2 raised to power 3 minus 1. So this is 2 raised to power 4 plus 2 raised to power 2, right? Okay. So this will be not 8, it was a 16 plus 4, that is going to be 20. Okay. We are getting the right answer. Weird formulas. Really, I to even hate these formulas, right? Especially the formulas of this asymmetrical, that is worst. Right? Because the problem is not with the formula, the problem is all the formulas are same. In stereoisomer, you have 2 raised to power n minus 1, 2 raised to power p. In geometrical, you have 2 raised to power n minus 1, 2 raised to power p minus 1. So there's a very slight difference in the formulas, But some teachers also will not give you the formulas, right? They will say that, okay, this will happen, right? But how this will happen, right? So this is the formula, yeah, you have to understand, right? Formula you have to see whether it's symmetrical or asymmetrical, right? So here it is symmetrical. This is how you are going to calculate for symmetrical. Similarly, for this also you will apply the same formula. If you apply the same formula over here, it will turn out to be, wait a minute, let me just calculate it here. Here n is equals to 4, right? N is equals to 4 and P will be equals to 4. This is even, so it will be, P will be equals to 2. So here it will be 2 raised to power n minus 1, that is 3, right? Plus 2 raised to power P minus 1, that is 1. So 2 to 8 plus 2, that is, it will turn out to be 10, right? Okay, and here they are telling us this to be 2. So here the answer is 10. Okay, here the answer will turn out to be 10. Here it is 1, 2. This I told you that this will not show geometrical isomer. This will be 0, right? And this will be 20, right? So answer is, good question this is. First and A and D is the correct answer. Okay? Okay? Okay, beta? Chalo. Right? So this is a good question. Right? Because see, they have asked you, the panga is only symmetrical. Asymmetrical to 2 raised to power n, what's the big deal in that? But asymmetrical, you have to be very alert here while solving this. Okay? So guys, we have done the optical isomers also. Now I think maybe 30-40 more minutes, right? Okay, so now let us do RD, RL, RS and DL configurations. Okay, let us do RS and DL configurations. After that, conformers, and one question of conformer I'll teach you. Then after that you are free. ठीक है, चलो. Formulas here, I know they are very confusing. That's why I'm telling you that what you do, just on some page, make 3 charts, right? On those 3 pages, write geometrical, stereo, and optical, right? So you have to paste the formulas, right? Okay. So you have to paste the formulas in front of your wall and you have to read it daily, daily, daily. Formulas are confusing, I know that, right? Okay. But that's the only thing that I have for you. Na? I can't change it here. What to do? They ask you questions based on that, right? Now, beta, here the same thing, CIP rule will be applied. That is priority basis. So I'll just tell you how to calculate RS and configuration, right? Always remember, if the lowest priority group is on the vertical position, vertical means this position, right? Then clockwise will be, clockwise is R, anti-clockwise is S. Okay. If lowest priority group is on the horizontal position, right, then clockwise is S and anti-clockwise is R. Wait a minute. Let me just see this. Okay. How much more time it is going to take? Guys, maybe 30 minutes more, okay? Chalo. Now, that's it. Now, let us solve this, right? I'll just tell you the way to solve. See, if they ask you R and S configuration, they will not ask you. I will be here till the lecture end. Very good, yaar. Very good. So happy for your dedication. So, RS configuration. So, beta, just remember this thing that if they ask you this kind of question, they will ask you a very simple question in JEE mains. In JEE advanced, they can ask you good question on this. But in JEE mains, if they ask you very simple question, they will ask, right? That's why I am teaching you this. Rather than skipping this thing and you see this simple question in the exam, it's better to do it, right? Because it's not that of a big deal, right? So in E and Z, we will giving priority on one carbon. Here we are going to give priority to these four groups. Priority will be same as we have done before also, right? Okay, it is same only. We know that here the first is oxygen, here the first we meet is nitrogen, here first we meet is carbon, and this is hydrogen. Carbon will be lowest because it is having the lowest atomic number. Oxygen will have the highest priority because it is having the highest atomic number. Then you have nitrogen, then you have carbon, right? So based on the atomic number, give the priority. Now see from 1 to 3 where it is going. From 1 to 3, as you can see, from 1 to 3 it is moving anti-clockwise. Anti-clockwise means it is, see, anti-clockwise, always remember anti-clockwise means it is S. But if the lowest priority group is on the horizontal position, cancel this and convert it into R. Okay? If lowest priority group is on the horizontal position, then anti-clockwise will be R. Okay? Chalo. One more question we will see by this. Beta, here you have CH2, as you can see here. Here you have CH2, CH3. Right here, this is CH3. So how you will calculate this, everybody? This is CH2, CH2, CH3. Right? This is CH3. See, lowest priority will always be given to hydrogen. So you can just give it fourth priority. First priority is given to halogen because it is the highest atomic number. Now here you have C and C common. Common will be cancelled. Hydrogen and hydrogen, hydrogen and hydrogen common, common will be cancelled. Same way, beta. This we know that here you have hydrogen and here you have the next person he is meeting is carbon. Carbon has the higher priority, so it will be 1, 2, second priority here, third priority here. Then you will say, ma'am, hydrogen and hydrogen. Beta, this is CH3, this is H. Here too I have cancelled C and HH, then I got hydrogen. Okay. So here what is the rotation? Rotation is 1, 2 and 3. It is a clockwise rotation. In clockwise it is R. But condition is hydrogen should be on the vertical position. It is on the vertical position, so answer will be R. Got it? Okay. Okay. So that is how you identify R and S. Now, why I have told you R and S for this kind of question? If they don't directly ask you R and S, they can ask you enantiomer, distereomers. Students find it very difficult to pass the plane, see the symmetry, right? Most of the students, they do mistakes in that, right? That is why we have this trick for you. Now, if both are R, then identical. If both are S, then identical. If one R, one S, then it is enantiomer. That means if you have one chiral center, right? One chiral center. This is one chiral center. We know that this is one chiral. This is one chiral. Now, better you just draw this, okay? Give the priority. We know that hydrogen is least priority, fourth priority, right? Chlorine is having the maximum atomic number first. Then you have fluorine. Then you have deuterium. These two are isotopes. Deuterium is more priority as compared to hydrogen. So here it is again, this is third priority, this is second priority, this is first priority, this is fourth priority. Now beta, just see this. This is 1, 2, 3. It is going anti-clockwise. Anti-clockwise means it is S. But here fourth priority group is on the vertical position. So answer will be remain S only. What about this one? It is 1, 2, 3. Again it is going anti-clockwise. Anti-clockwise means S. Again the fourth priority group is on the fourth vertical position. So it is also S. This is what I was telling you. If both are S or both are R, that means same configuration, then it is identical. If one is S, one is R, then it will be enantiomer. Okay? Got it? Okay? Okay. Okay, if you see this as, if you're saying this as enantiomer, they are not the mirror images, guys. They are not the mirror images of each other. Okay, so they are exactly the identical. If you see this with chlorine, you have fluorine. With chlorine, you have chlorine. You have fluorine and hydrogen. Wait a minute. Wait a minute. Wait a minute. 1, 2, 3. Oops. Opposite, I think. Yeah. This is not coming out to be identical only. If you see directly only, this is not coming out to be identical. Oppositely, I have drawn. Okay, so this is 1, 2, 3. This is clockwise, yeah. This is clockwise, not anti-clockwise. Yeah, this is clockwise. So clockwise means it is R, right? So it is R and this is S. If one is R and the other is S, then it will be enantiomer. One is R, other is S, then it will be enantiomer. If both are R or S, then it will be identical. This though you can also see directly only because fluorine is having deuterium and chlorine. Here fluorine is having chlorine and hydrogen. Definitely it is not identical. Right? Okay? Got it? Chalo. Next is two chiral carbons. See, in one chiral carbon, though you don't even need to draw this R and S. You can easily identify that without calculating R or S. But the problem occurs in if you have two chiral carbon, right? Here remember, if both are opposite, that means one is R, other is S, one is S, other is R, or one is R, other is S, one is R, other is S, or one is S, other is R, or one is S, other is R, one is R, other is S. That is opposite. That means on that same carbon, the configuration is opposite. Right? If both have opposite, then it is enantiomer. Right? If both are same, then it is identical. If one opposite and one same, then it is a distereomer. Okay. Now, let's talk about this particular, whether it's enantiomer, it is distereomer, what it is. If you talk about this particular thing, we know that this is chiral. This is fourth priority. This definitely is the first priority because here after carbon it will meet bromine. Here after carbon it will meet hydrogen. So this is the first priority here. This whole group is the first priority, right? Not even the first, this is the second priority. This is the first priority. Here directly you are meeting chlorine. Here directly you are meeting carbon. Then you are meeting bromine. So this is the second priority. This is the third priority, right? So it is 1, 2, 3. It is anti-clockwise. It is, sorry, clockwise. It is clockwise. Clockwise means you have R configuration. But fourth group is on the horizontal position, so it will be S. So you can just write it here S. Okay, just write it here S. Okay, what about this one? Fourth priority, first priority, this is second priority, this is third priority. Again, this is 1, 2, 3. This is anti-clockwise, right? This is anti-clockwise. Now, anti-clockwise means S. But here fourth group is on the horizontal position, so it will be R here. So here you can just directly write this is R. Okay, guys? Beta, try to solve it yourself also. Because ma'am is tired. Ma'am can also do something wrong. I don't want to, but sometimes in hurry because I am also drained mentally. Right? So you also solve it yourself. Just don't look at me. Okay? Solve it. Have I calculated it right? Both are S. Both are coming out to be S. Or one is S and one is R. Everyone, what's your answer? Acha, this is fourth priority. This is first priority. This is going to be third priority. This is going to be second priority. So this is 1, 2, 3. This is again anti-clockwise, right? Anti-clockwise means it is S. But fourth group on the horizontal, so it will turn out to be R. So this is basically your R. It is basically R. What about this one? Fourth, first, second, third. 1, 2, 3. Again it is clockwise. Clockwise means it should be R. But fourth group over here, so it is S. So it is coming out to be S. Both are coming out to be opposite. In my case, though, both are coming out to be opposite. Have you also calculated the same thing? So it should be both are coming out to be opposite. That means it should be enantiomer. See, we can also verify this. How? They are mirror images, but they are not superimposable. So they are non-superimposable mirror images are always enantiomers. Okay? Okay, got it? Yes. Got it, bachcho? Enantiomers these are. Okay? Yes, for previous example, both are S. Beta, this example, this one. I too think this is S and R only. Wait a minute, let me check here. This is, if this is 1, this is 2, this is 2, this is 3, this is 4. So it will be 1, 2, 3. It is coming out to be anti-clockwise. Anti-clockwise means S. But here fourth group is on the horizontal, so it will be R only. It is coming out to be R only. Okay? R only it is coming out to be. Okay? So these are enantiomers. Chalo. Next is, that's it. Now let us see DLN configuration. So DLN, though you don't even have to do this. A simple trick here. DL configuration simply means last chiral carbon, either OH or NH2. If it is on the right, just remember DR. Diksha ma'am is always right. D and small l, right? So capital D means OH on the last chiral carbon is on right side. If it is on the right left side, it is capital L, right? So let me give you the examples here. Here, this is the last chiral carbon. This is the last chiral carbon, right? OH is on the left side, so this is L. OH is on the right side, so this is D. Okay, this is D. Okay, what about this one? Here also, this is last chiral carbon. This is last. Don't look here. Don't look here. I am talking about last chiral carbon, right? So here OH is on the left side, it is capital L. OH is on the right side, it is capital D. Okay? It is capital D. Chalo. Next is very, very important. If you have DLN configuration, if NH2OH selected according to NH2, that means if you have OH and you have NH2 also, then NH2, then you will not look for the last chiral carbon. This is only if you have NH2 and OH both in that particular molecule. In that case, you will not look for the last chiral carbon. You will only see where you have NH2. Based on NH2 only, you will tell NH2 is on the right side, so this is capital D. You will not even see where is OH. You will not look for last chiral center. Okay? Beta, this is not levo and dextro. Oi, hoi, beta, no. This is not levo-dextro. Levo-dextro is small d, small l. That has no relation here, okay? Levo-dextro has no relation. Okay? Chalo. Done? Done? Okay. Now, let us do some important concept here, right? That is conformers, based on which it is highly possible they can ask you the question. Okay? So, very 10-minute concept it is, right? So I'll just give you the basically stability order you need to tell me. Beta, conformers, right? Firstly, we will talk about the conformers of ethane, right? We will talk about the conformers of ethane. Methane will not exist because for conformers, you need to have proper rotation, right? That is why if a question is asked, how many conformers exist for methane, right? Or how many conformers for methane, there are infinite conformers. But the defined conformers are very less. Okay. So we'll talk about the defined conformers here, right? So firstly, let's talk about the conformers. They exist in Newman structure. Newman structure is like a Mercedes. This I'm drawing with dark pen is showing the front carbon. The one that I am showing with dotted is showing the back carbon. So one, I will show it like this. Okay. other I will show it like this. Okay, one I am showing it like this, right? Other I am showing it like this. So I'll just directly tell you in a summarized manner, because see, we don't have that much time now, right? So that's why we will only learn what is required for your exam. Now beta, the angle, right? Usually though I teach this by 3D models, but now we don't have that much time, right? So we have to adjust. Now guys, let us see one thing here, that basically here what you have, it's like this. If in the front the hydrogen is at this position, in the back the hydrogen is at this position. If I'm talking about this dotted line, if the front hydrogen is like this, back carbon is completely escaped by the front carbon, right? So this angle is called the dihedral angle. The angle between this forward and backward atom is called the dihedral angle. For example, they are at this angle, so it will be 60, 30, 120 according to that, right? So now I am going to talk about ethane. In ethane, we know that there are two carbons, one is front, one is back, then you have hydrogens here, right? Now beta, two kind of conformers will exist for ethane, right? Two conformers are existing for ethane, and these two conformers, you need to tell me which is more stable, right? You need to tell me which is more stable. Now the one which is like staggered, that is called staggered. Staggered means like scattered, okay? So this is called staggered. And this, have you seen eclipse, right? The apna solar and moon eclipse, right? So what is basically that? When we are not able to see the sun or the moon, right? So basically that is called eclipse. In the same way, when this hydrogen is hiding the other hydrogen, that is called the eclipsed structure. Eclipsed structure. Always stability they will ask you. If they ask you the stability, staggered is more stable as compared to eclipsed. Okay? Staggered is more stable as compared to eclipsed. So staggered will have low energy, right, as compared to eclipsed, right? Because there are less repulsions here. Here you will have more repulsions, right? Because of that, staggered is more stable as compared to eclipsed. Got it? Yes, bachcho. Now, next they can ask you is conformers of bit a very small topic, yet from here direct questions can be asked. Conformers of butane. So basically there are 4 specific conformers of butane that I'm going to draw here, right? Okay. Okay. I'll tell you how it is done. Okay. So 2 are like eclipsed only, right? When they are at like next, like covering each other, then there is a difference of 60 degree, then again covering each other, right? Then again at angle of 60 degree. We know that in butane what you have? In butane you have 1, 2, 3, 4. That means 2 methyl groups you have as substituents. Okay, that is why this is very important. 1 methyl group, this is 1, 2, 3, 4. 1 methyl group on this carbon, this is my front carbon, this is my back carbon. This is the substituent. So this and this are the substituent, this is my front, this is my back carbon. This is how I am going to draw it. So basically the same way I am going to draw the conformers here. For example, this is CH3 here, this is H. Let's assume that CH3 are overlapping each other. Okay, we will keep 1 as constant now. Okay, we will keep 1 as constant. Got it? We will keep 1 as constant. Keep the front one as constant, rotate the backward. Right? Okay, guys? Keep the front one as constant. That means this that I have drawn by solid line, that I'll keep as constant. So this is CH3, this is H, this is H. This is CH3. Because beta, conformers are based on the rotation only. Okay? So that's why we are doing the rotations here. Now I will just rotate the back one. Here the back that I have shown by dotted, I'll shift it to 60 degrees, so it will be here. Right? Then this also to 60 degree to 60 degree. Right? Again, I am shifting it to 60 degree. This is here. This is H. This is H. Again, shifting it to 60 degree. Wait a minute. CH3, CH3, CH3. This is CH3. 1, 2, 3, and 4. Yes, this is CH3. Okay, this is H and this is H. Okay, so these are the 4 structures. Okay, guys, so these are the 4 structures. Now let us see which is what. Right? Okay. So here they are hiding something, they are hiding something. So both of them are eclipsed. Okay, this is also eclipsed. Here CH3 is hiding CH3 only, so it is fully eclipsed. I am also telling you guys the method of learning this. This is CH3 is hiding hydrogen, CH3 is hiding hydrogen. That means basically they are not exactly one atom is, it's not like same CH3 is hiding the CH3. They are hiding the different atom. So that is why this is half eclipsed. Okay, so we'll just call it as half eclipsed. Okay. Here CH3, CH3 are opposite to each other, so that will be called as anti. Here CH3, CH3 are next to each other, so this is called as gauche. And girls are gossiping, G for girls, gossiping, and girls are always sitting next to each other while gossiping. So next to each other, gauche, just to remember. Now the stability order is what they will ask me in the exam. The stability order, write it. Anti is maximum stable. Why? Because no repulsions are seen here. Then you have gauche here. Then you have gauche. Then you have half eclipsed. Half eclipsed. Then you have fully eclipsed. Then you have fully eclipsed. Okay, that is the stability order. Okay, guys, that is the stability order. Is that clear to everybody? Is that clear? Now I'll give you one question of your JEE that they can ask you. Right? Gauche effect. Based on gauche effect. What is gauche effect? See, based on gauche effect, what they will ask you, that you have some molecule. Let's see, it is OH here, H here, H here. Let's say here you have fluorine. This is H, this is H. Okay. So, another is this one. This is the gauche structure. Here with the same structure, I am forming the anti-structure. Okay, I am forming the anti-structure. Where F and OH are on the opposite side. This is H, 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 H. Now, why I have like given you this example? Usually anti is more stable, right? Okay. Why Kritik is laughing? Usually anti is more stable. But here you have this thing. This is hydrogen, right? Here this is fluorine. It is having hydrogen bonding. Because of this hydrogen bonding, more the hydrogen bonding, more the stability of that compound. That is why in gauche effect, gauche is going to be more stable as compared to anti. Gauche is going to be more stable as compared to anti. Reason is the hydrogen bonding, right? Okay, chalo. Done. Acha. Last topic of today's conformers of cyclohexane. Okay. Okay, guys. Sure. Just give me a second. 1040, 1050, huh? Last topic, right? Firstly, to let us solve this thing. Right, firstly, let us solve this question. Then the last topic is conformers. There also they will ask you the stability if they ask you. Right? Okay. Okay. The incorrect statement regarding the conformations of ethane is ethane has infinite number of conformers that I told you. The dihedral angle of staggered conformation is 60 degree. Dihedral angle is the angle between them. Staggered conformation, beta, they are talking about this particular conformation, right? So this is the angle that they are talking about. This is the angle that they are talking about, right? Okay. So next is eclipsed conformation is most stable conformation. Eclipsed conformation means they are talking about this conformation. Eclipsed is the most stable. Due to repulsion, staggered is the most stable. Right? So here we can say that third is the incorrect statement. Eclipsed is unstable. Staggered is more stable as compared to eclipsed. The conformation of ethane are interconvertible to one another. Right? This is what I was telling you. When you're rotating, na, they are converting back to each other. So that is interconversion only. Right? Okay? Infinite number, always remember. Staggered, the angle I told you, dihedral angle is the angle between them. And they will ask you basically the stability orders only. Right? Now, the last thing we are going to do is the conformers of cyclohexane. Let's do it. Otherwise, I'll die here only, guys. The conformers of this was really a big topic. Conformers of, and I was like, I don't want to skip even a single thing, right? That's why I'm still here. So guys, first thing is just remember CTBH. CTBH. First is, what is CTBH? Chair, twisted boat, boat, half chair. This is the stability, okay? CTBH. Just remember CTBH. What is chair conformer? Okay, what is chair conformer? Chair is like the sign of Twitter. Okay, chair is like the sign of Twitter that you have. Wait a minute. Okay, it's like a sign of Twitter that you have. This is the chair conformer, right? This is the chair conformer. Then you have the twisted boat conformer, right? Twisted boat is like, you can say it's basically like a kite, right? Two kites you draw, right? Okay, two kites you draw, right? And this is like a twisted boat. Okay, this is basically a twisted boat. Boat conformation is like a boat, right? Okay, boat conformation is like a boat. Boat is basically like this. 1, 2, 3, 4. Wait a minute. 1, 2, 3, 4, 5, 6. Okay. So this is the boat conformation. Last is your chair conformation. I don't have space to draw chair conformation. Okay. So chair conformation is like a sofa that you are sitting on. Okay. So you have a sofa where you are sitting on, right? So this is your sofa that you are sitting on. 1, 2, 3, 4, 5, 6. Okay. So this is how I remember this, right? Twisted boat. Otherwise, if you start making the structures of like proper book, then you will get confused, right? It is boat and this is half chair. Chair is a proper chair, like proper chair, like a Twitter sign. I to remember this by Twitter sign. This is a kite. Two rhombus you have to make, right? Okay, okay. It's like a kite, two kites, right? So here boat is basically here also you can draw something like this to show the twisted boat. Okay, so here boat is basically like a boat and chair, half chair is like sofa, right? Okay. I don't know you. I think you are cracking fires because of we have completed such a big thing, है ना? Oh my God, what a big lecture, yeah. What a busy day. What a busy day, right? Isn't it? Oof. Hats off to yeah. Firstly, how you are sitting here for how many hours, yeah? 6. Oh my God, it's almost 5 hours you are sitting here. Firstly, though, clap for yourself. Okay, clap for you. And we have completed the isomerism part. Everything we have completed, right? Each and everything. Like I have not even skipped a single thing here, right? Not even a single. Starting from a simple structure to tautomerism to metamerism to previous year question to calculation of geometrical, optical, and stereo center, conformers. Conformers may they will ask you maximum this only, right? And then what else? What else we have done? I think that's it. DL, RS configuration, and chiral, plane of symmetry, optically active, inactive, alenes, spiro, biphenyl compounds. Not even a single thing I have skipped here. I have skipped here. Like, so I am very happy about it. Today, when I was taking the lecture, when I was about to start the lecture, you know, yeah, beta, if you do this, this is more than enough, right? Okay, this is more than enough. Okay, this is more than enough. If you do this and if you remember this, that's a big thing, right? Chalo, shabash. So, firstly, clapping for all of you guys. I'm so happy for you that you are putting so much dedication in your exam, right? Now, same dedication I want to see on Sunday as well. So on Sunday, we have the lecture of naming reactions, right? Where we are going to do naming reaction, the previous year questions, right? And that is also going to be a very, very important lecture. But guys, I need your support, okay? How your support? Because see, if the teacher is standing here, if the students are not enthusiastic, how I was able to pull off to like 5 hours, right? And it's not the content that I have given you is actually of 10 hours, right? So much I have like continuously I've been speaking. It's very tough to speak for 5 hours continuously on daily basis, right? So uh, reason is you only. Reason is you means when you are there, when you are, you know, Kritik, Janka, JEE, then Shubham, right? Entity. These are some of the students who have been here like from the first minute this lecture started, right? I know some of you don't usually write it in the comment section, but you are there, right? Okay. Ma'am, your qualification. Yeah, what you have to do with my qualification? But still, if you're asking you, I'll tell you, right? But I don't think so. You know, a teacher is never, I think, 10th. Your friend can also be a very good teacher if he has a knowledge, if he or she has a skill to make you understand things. Even a postdoc, PhD, even a doctor cannot be a good teacher if they don't know how to explain to the other person, right? But yes, if you're asking, then beta, I am BSc chemistry, MSc organic chemistry, and beard, and I have qualified CSIR net. So yes, in chemistry only, right? Okay. So yes, I think I'm enough qualified to teach you, right? So you don't need to worry about that. Part was little tough, so it was little quiet in the chat box. Yeah, there I thought that guys are not even speaking anything. Yeah, the calculation part, basically the formulas are tough, right? The formulas are tough, beta, but I have combined the formula for you. Just do one thing after the class. After the class, take a paper, not today, I'm saying maybe tomorrow morning, get up, right, with a fresh mind. Notes will be provided to you on the Telegram channel and on the Jungle Box. Okay, on the Jungle Box, it will be uploaded. Now, what you have to do, you just have to go there, download it, see that particular page where I have written geometrical, stereo, and optical isomer, the calculations. Paste it on your wall and see it on daily basis. Right? Go through this on daily basis. You have to do that. Right? Otherwise, questions are not tough. Questions are easy. But yes, the formula cramming part is little tricky. Okay? Chalo. Okay, beta, I'll convey this to sir. Don't worry, I'll convey this to sir. Okay. Now, I want all of you to share this session among your friends, right? Even your NEET friends, JEE friends, boards friends, right? All of them share this among your friends, and also don't be a conjuice, yeah. Okay, share this among your friends. So, this will also help them also, right? Okay. And one more thing, I see that you guys don't comment, right? Okay, and I'm very, very greedy for comments. I'm literally very greedy for comments and likes. Okay, so because so much hard work I put for you, can't you just like this and share this and comment down what you feel about this lecture? So I want you to comment it down what you feel about this lecture. Are you excited to do naming reactions, important reagents along with me in this particular series? If this series, you make the series a hit, then definitely there will be an amazing series for physical chemistry as well. That's my promise to you, right? Okay, but if this series is a flop, then beta, then for whom I am teaching here, right? Okay, so share this, like here, comment here. Are you excited? Whatever you want to say to me, right? Okay, okay then beta, bye bye, take care, see you all in the next class, that is on Sunday at 5 p.m. guys. I'll take the class. I think 6 p.m. तो बहुत ज़्यादा, it comes too much, right? So that's why I'm going to take the next classes at 5 p.m. Okay, I'll take the next classes at 5 p.m. Day 3, day 4, day 5 will be at 5 p.m. not at 6 p.m. Okay, chalo. Okay then, bye bye, take care, see you all in the next class, bye bye. Oh God, Ran is like, comment and like is okay, but share no way with competitor. Arey, this competition, you should know what is the competition. It's not like you will not send this to them, then they will not be able to study only. They will study. If someone wants to study, they will study, right? They will themselves find, right? So you're not increasing the competition. You are just blinding yourself that other students are not studying. Actually, they are studying, right? Okay, chalo, bye.